Hi, good morning and welcome to the third European perfSONAR user workshop. It's obviously being held, hopefully you've seen the agenda on the Chown events page. It's being held over 2 days, today and tomorrow, both from this time, 12 o'clock UK time to about 4 o'clock UK time. We've got a lot of content and hopefully a good amount of discussion time. The majority of the content today is focused on new and interesting things that are being tried with perfSONAR. So for example, we have talks on perfSONAR and WiFiMon. We have a talk on potential integration of perfSONAR and MicroDep, looking at things like routing changes and how we might monitor those. We have a couple of talks looking at using perfSONAR in 100 gig networks and the lessons learned there. There's a 100 gig mesh that the WLCG, the CERN experiment people maintain. They've been looking to improve the measurements they've achieved there. We'll also have a talk from the EPOC people in the States about what they're doing. Mark Feit will be talking about using perfSONAR for security monitoring and testing, checking when services appear or disappear, especially services you might not want to be visible, becoming visible, rather than the usual use case of monitoring for things being available. And then tomorrow, if you can join as well, we'll hear about what's happening with PMP, the updates to the performance measurement platform, where we've got perfSONAR nodes, small nodes scattered around the best part of 40 NRENs in Europe and what's happening there. And that will include the talk by Lubo on analyzing that data, looking for trends and patterns, which is in itself an interesting trend. People are starting to look for ways to take the measurement data that tools like perfSONAR can produce and to more intelligently analyze, look for trends, predict potential issues and faults that are happening. And we'll also hear a good amount about what's coming with perfSONAR 5.0, which is not too far away now. So, for example, there's a significant change to the back end and how the data is being held, and we're going to hear about that tomorrow. So the new back end will be a big part of that. And then we'll be closing with the post 5.0 roadmap. So what's going to happen beyond the initial 5.0 release. And I think what will be good as well is that over these 2 days, we're going to have the opportunity for both users of perfSONAR and developers to interact. So there will be some talks by people that are perfSONAR developers and talks by people that are using perfSONAR. And I think it's very important over these 2 days that we listen to each other, understand what we're both trying to do, and align perfSONAR to what its users want to do and want it to do. So we're going to have a good amount of discussion time for that, and particularly at the end of tomorrow's session. But first of all, I'll hand over to the next speaker, who I've completely forgotten who it is, who's going to talk about what was agreed in the second perfSONAR user workshop, what's been done on that, and what's happening with the evolution towards perfSONAR 5.0. So sorry, that's Antoine. Back to you, Antoine.
Yeah, thank you, Tim, for this introduction, and welcome to every one of you to this third perfSONAR user workshop. So let me switch over to the other presentation I have here. To give you an overview of the latest perfSONAR developments and news, the latest activities we have been witnessing and done in the past month since actually the last user workshop we had held last year. It was also held online in the same Zoom room a bit more than a year ago. So back then we had it was also a two-day events like this one with around 15 presentations from 11 organizations. We had quite some nice participation from perfSONAR users and developers, around 70 participants in total. Let's see how many we can reach today. And then at the end of the workshop, we did a small survey. We collected your feedback after the workshop as well, and we noted that you asked for, and that's one topic we discussed quite a bit in the last year event, is the OS support, or which OS you can run perfSONAR on. You ask for easier access to data, to measurement data. You ask for better improved documentation and guides. So these were the main topics you users were interested in. We'll see how we tried to address that since then, and how we can even improve in the future. So what has happened is that we made some new maintenance releases, the 4.4 series, which were mainly bug fixes and just a very few small features being added, but nothing major. Then at the end of last year, in November last year, we held the perfSONAR Day, organized by Internet 2. There were some nice participation there, nice presentations, mainly from developers. And if you've not been able to attend this meeting, we'll share with you some news and some development that has happened, that was presented there and has happened since then in our team and in the perfSONAR development group in general. Unfortunately, although we had planned for it and we announced it in the last year user workshop, we didn't manage to have a 5.0 beta release. We worked on it a lot, but we couldn't find, we couldn't reach a point where we were satisfied enough to make it a beta release, and we needed to sort out every details and make sure that this release is going to be in as good quality as the previous one. So we also didn't want to rush things, because we know this 5.0 will be a big change, and we're going to talk more about this today. So the beta is not out yet, but it's getting closer, and so it's really getting closer these days. And we'll discuss actually the beta release tomorrow in one of the presentations. So we have been clearly working on it in the last year, with lots of different things happening and going on, and that's what we want to share with you in the workshop today. A bit of update on about the deployments as well. So we only know about the public perfSONAR deployment that exists around the world, and we can say it's somehow stabilized for a few years now, around 2,000 perfSONAR public instances. We know that there are a lot more actually, and a lot of perfSONAR instances are not published on the lookup service, where we make all perfSONAR nodes known to anyone that uses perfSONAR around the world. But we can see from the map that the deployments are everywhere in every continent. and we can see that the spreads of the deployment is increasing, I think, and we have good coverage of in a lot of different countries, in a lot of research and education network around the world. So if we look closer at the GÉANT service area, we can see that nearly every country in the GÉANT service area, there are just a few exceptions, have at least one perfSONAR deployment, and usually there are multiple ones in national and research and education networks or in research networks. That depends, and they are different and various. So thank you very much to all of you users and perfSONAR administrators, because this wouldn't be possible without you. And the more public perfSONAR deployments we have, the more useful perfSONAR is. So that's clearly what we're looking for. A bit more detail to come about the software updates and what this minor releases or a series of minor releases that happened during last year. A few new features were added, like the loopback throughput tests, being able to use AS autonomous system numbers in p-scalar limits. There's a minor feature, but very useful feature for the to whitelist archives in the graphs configuration, so that you can easily access data coming from different archives when you're displaying this in MatDash, for example. And the RabbitMQ archive has been also completely changed. So these were clearly some minor fixes, and along with that, some minor new features, and along with that, quite a few bugs and security fixes were released as well. So this happened while we were doing the development for the next major release that we're going to talk a bit more today, a lot more actually. So thank you all as well for this. We welcome your help in finding finding and improving perfSONAR. So whenever you find a bug, reporting it through our different channels is very, very useful to us. So last year we held this same workshop, and I wanted to come back to what we discussed and a few conclusions we made to see how we progressed from there, and to see what we still need to tackle, and where we can still improve, and what we can continue to discuss and share today. So to remind you about that, or if you didn't have the chance to participate last year, we had a different presentation from the user's perspective, and showing up different ways perfSONAR is being used. That was ranging from some 10 gigabit per second mobile testing happening in the University of Michigan campus, for example, to scaling up perfSONAR deployment. That was a talk from ASREN. Then we had some talk about setting up a central management server. We discussed CNAS deployment and how perfSONAR could be used in such a deployment. We discussed also some new tools and usage of those tools through pSCADR and new ways of doing measurements. We discussed pSCADR plugins development and how you or any developer can easily add new metrics and new measurements to perfSONAR. And we also discussed quite a bit the different operating system that perfSONAR runs on and how this will change in the future and in the upcoming release. So as a summary of some feedback received at the end of the workshop, you asked for some different characteristics of perfSONAR, and if we look, for example, in the OS support, you asked for no OS lock-in. We've been explaining you this in the perfSONAR Day event last year, but we are addressing the no OS locking, and we will continue to support different OS going forward. So we will continue to have Ubuntu support as well, and build perfSONAR to work on different architectures. So we can say that we have improved the OS support. You asked that, or some of you at least asked, that we stay near the edge of, instead of well behind the newest release of OSs. That for now, I have to say, we didn't manage that, and we are still a bit behind the releases, but we tend to stick to the more stable releases that are out there, and this is what we've done in the past as well. We will try to get a bit closer to the newest release, and there are some news coming up in this front as well. I'll be explaining that later today. You asked for some scriptable configuration. You ask for containerization, simple installs, and in simpler install for on-demand testing. That was already part of what we offered with some of our products and methods of installation. So we are going to continue that with Ansible and with Docker, so you can continue to rely on that. And you ask for easy export of measurement data. This is also going to happen with the new 5.0 release that you'll see that today. So I think all in all, we're quite in a good shape with regard to some feedback received at the workshop last year. So just to touch a few topics now, but we'll go into more details today or tomorrow. We still continue to support CentOS 7, but we'll move away from it in the future, and we'll continue to support Debian and Ubuntu, and we'll bring some newcomers into the OS support list as well. So yeah, we discontinued the support for Ubuntu 16 also in the last month, because Canonical itself doesn't provide support for it as well. And we've been working quite a bit on building up and setting up a new build mechanism that we called UniBuild, and that will enable us in the near future to more easily build RPM and Debian packages for all the perfSONAR packages that we provide, and for all the tools we provide. It's a complete set of tools that really smooth the way the different packages are built and are released, and that we can apply to all the different perfSONAR repositories that we have, and we have quite a few of them. So we are still finishing the last touches on that, and still integrating that in the build pipelines of every tools that we have. But it's progressing well. We did a sprint, development sprint a few weeks ago around that topic. We're going to do another one next week. So that will help us bring you perfSONAR 5.0 in the coming weeks. And that's also part of the reason why we've been delayed the 5.0 release the last month, is because we were looking at changing all this build infrastructure and making sure everything was improved before getting this release out. So talking about the 5.0 release, you know there is a new backend, and we'll discuss this a lot more today and tomorrow. So I will just go quicker a bit forward to talk about something else that we've been also working on in the last month. Actually the last years, because it's a development topic for at least one developer in the GÉANT team. Lubo is doing a lot of development on a new tool that we called PSGUI for on-demand measurements. So that's a tool that's replacing another tool that we had some years back, and that can help network engineers work with a graphical interface to access pSCHEDULER and to launch on-demand measurements. There's quite a lot of features going on in the first implementation. We've been testing it in a closed group in the GÉANT project so far, and presenting it and in a few events, and it's now getting ready for a public beta that should happen in the coming couple of months, and hopefully it will help you in your day-to-day work with perfSONAR and with pSCHEDULER. I have here a few screenshots of the interface, so you can have a glance to it. So that's how you can set up a measurements between two different nodes here. For example, the list of nodes is coming from a mat-dash setup, but it can be augmented and changed through a configuration file, and then you choose the test parameter. At the moment, it's made in tailored towards the most used and well-known perfSONAR tests, that are the throughput, latency, trace, and run trip time tests, but will also provide access to the other pSCHEDULER tools in future versions. So when you run a throughput measurement, then you have directly the visual representations of the results directly in your browser window. You can do the same with latency, and then an histogram of the packets and the delays of these packets is displayed on your screen. So that's a new tool that we've been working on also this last year, and that we're going to present you in the near future. And as usual, yes, we still use the same channels to track progress and engage with you, our users. You know the GitHub issue tracker. Use it whenever you feel you need it. You need to reach for us. There are the user lists. You know them as well, and we'll post some links to it at the end of the workshop tomorrow. And we continue with our usual meetings and calls, and we welcome also your participation as users. If you want to provide feedback or share your experience with perfSONAR. And so to come back to our workshop today and to the different topics that we're going to talk about, we structured the agenda so that the first day it's mainly focused on user experience and different use cases, but not only. And the second day more around what the developers want to present and what want to show you what's coming up mostly what's coming up in the 5.0 release and some other new features that we are currently working on and where there is work in progress. So yeah, thanks for being here. And yeah, the structure of the agenda of the workshop today is that we have a set of 3 presentations and then some time for question and answer and then a break. And we have 4 sessions like that today, and again 4 sessions tomorrow. So I'm going to continue with the next presentation, which is from myself as well, and we'll be addressing your question after this. But you're welcome to post your question to the chat whenever you want.
There is actually a message from Timur, if you want to take a look, and the question is when the UI will be available for measurement for open to public. So I will send Timur the link to do the tests for us and get back to us. So yeah.
Yeah. Good.
Sorry, just to actually to expand on that question, if it is going to be open to public, is it going to be password protected or not, and how do we make sure that it is not abused? Or you think that PS Scheduler already has mechanisms to ensure that somebody's not constantly running those tests when they're not supposed to?
That's a good question. Probably in the beta we'll make it we'll make the access only through full protected login to assess that and to verify that. But normally, yes, the pScheduler API is this tool just use the pScheduler API, and the pScheduler API is open and is available to anyone that uses perfSONAR. So that's probably true that having a graphical user interface will add some more stress to the and more opportunities for people to use it, and maybe some bad guys to use it. So we'll need to monitor that. But normally, pScheduler should have good protection against misuse as well. So
okay. And sorry, you mentioned that we can choose the source and destination from. So what was the list from where we can choose it?
So initially, the first release of this tool will focus on the list of perfSONAR nodes that are part of the PMP setup, so the performance monitoring platform that's run by GÉANT. Okay. But it's a list that's going to be increased in the future and probably during the beta itself. And then at some point, the roadmap for this tool is to be able to list every perfSONAR host that is in the lookup service, and so that any perfSONAR host around the world can be used with this graphical interface.
All right, thank you.
Right, thank you, Timo, for the question. Yes, Tim?
Yes, Antoine, you mentioned the stopping support for CentOS 7. Is the timing for that going to be aligned with the end of life of CentOS 7, which is in the middle of 2024, or might it be sooner?
Yeah, yes, that's what we've been advertising since Red Hat made this change, is that perfSONAR is going to run on CentOS 7 until the end of support of CentOS 7. Yes.
Right. Good. Thank you.
Okay, so then I'll continue with my second presentation, which is an overview of what you can expect in the next major version of perfSONAR. And I must thanks Andy, Daniel, and Luan for this presentation, because it reuses mainly a lot of the material they presented in the perfSONAR Day last November. So yes, we are actually calling this next release the 5.0 because the change from 3.0 to 4.0 was almost 5 years ago. So it's quite some time ago, and the change we bring into this new version are quite important. And the most important change, but that's not the only change part of this release, is the change in the backend, in the archiving mechanism that we have in perfSONAR. So currently, when you have a perfSONAR setup and you see that something is going on, you notice it through your mat-grid, and there is some color change in your mat-grid, and you see that there is an issue, a performance issue going on between some host or in some part of your network. Here it's on the ESNet network, for example. When you click on the grids in the squares in the mat-grid, you get access to the detailed measurements, and you can see that there is clearly in one direction a throughput that's lower than in the other direction, and that's clearly a sign of an issue, of a performance issue. perfSONAR confirms that with showing you the packet loss that happens as well, and that the latency also is choppier, is very irregular. So you want to know more about what's going on, where this performance issue comes from, and try to resolve it as a network engineer. And usually when you want to do that, you need to gather other sort of data. You need to have interface statistics. You need maybe to have flow data. You need to have information coming from your optical layers, and probably some more. And obviously the measurements coming from perfSONAR. And you want to look at all that at the same times. We clearly want to make perfSONAR easier to use in this kind of situation. And what we think was the first step to address this problem is looking at the metadata and the data that perfSONAR archives and that perfSONAR stores in its backend. So an archive in the perfSONAR terminology is where we store the measurement. And this is where all the visualization layers, the different visualization layers that we have be it the MATDASH grids, the graphs, or other ones. They're querying this archive. And for up to now, in the existing releases of perfSONAR, the archive, the default archive was SMOND. It's a tool that we, perfSONAR developer, have developed and maintain. It's actually based on two different databases: PostgreSQL database for storing the metadata, and then Cassandra, which is a NoSQL database to store all the measurements. It has a REST API, and this is what you run when you install the perfSONAR toolkit, or when you install the perfSONAR central management, and you collect all the perfSONAR data in a single and central server. We want to replace it because it was very getting more difficult to maintain day after day. The stability of the tools that we used, and mostly Cassandra, was not good, and moving on to newer version was quite challenging because of the way we had integrated it with our code. And so we wanted to also move to a tool that we didn't have to maintain ourselves, so to free up some development time and be able to work on things where we clearly can add more value than maintaining an archiving solution that can be provided by other tools. And one obvious choice that came to us is using Elasticsearch and the different tools in the ELK stack, because it's widely used in the research and education community. It's well maintained. It's evolving a lot, and very versatile. So Elasticsearch is the backend. Logstash helps you build a pipeline to ingest the data and to push it to Elasticsearch. And then you can use different visualization platform to query for the data and display it in different ways. Kibana is the one that comes with Elasticsearch, but there is also Grafana that you can use easily as well. So we said Elasticsearch, but in last year, Elastic or the company behind Elasticsearch decided to made some change to their licensing model, and for open source project to continue to use their product, it was getting a bit difficult. But other contributors decided to fork the product and to provide different packages and a new version of it, a rebuild of the Elasticsearch engine has been called OpenDistro, and then now is called OpenSearch. And so that's what we will use for perfSONAR and the 5.0 release. We'll have a talk that goes into more details about this backend change tomorrow from the guys, the developers that worked a lot on it, and these are our colleagues and at RNP. They will be presenting this to you tomorrow. But if we already have a closer look at how it works, if you want to know that. So when you run a measurement with pSCALULAR, the tool that you're using, be it iPerf or WAMP or whatever other tool, hands over to the measurement to pSCALULAR, and pSCALULAR uses the HTTP archiver to send the data to Logstash, where we have a pipeline and some processing of the data before the archiving actually happens in Elasticsearch. So to make it work with the existing components of perfSONAR, we are introducing a piece of middleware that we called Elmont that mimics the Esmond API to the external world, so to the visualization tools, and that translates this API calls to a query to Elasticsearch. So that any application that's running and that's querying Esmond at the moment can continue to use the same API in the new perfSONAR 5.0. So that's quite a change in the architecture, but not a radical one, because we keep the same API and we keep a lot of existing components. So if we look at how the different package relationship are existing at the moment, we have the perfSONAR toolkit, which is based on the perfSONAR core bundle of package, and which can be either a test point installation, so without any storage, or with the Esmond backend. That's what exists today. And in 5.0, this will be replaced by a new archive package that will contain the open distro packages that will contain Logstash and that will contain or install Elmont. And so this is the only piece that's going to change. So the test point installation will not have this change because there is no backend, and it's for the toolkit and the central management bundle, and actually the central management bundle will go away as well, and you'll have more details again about all this tomorrow with some presentation from the RNP developers and from YesNet as well. So that's that's how Elmont works. It's a Python-free application. It's quite lightweight. It just translates the API calls, and then Logstash is used to process the data that's coming from pScaler and to be able to store it in a standardized way into Elasticsearch. So it does some normalization. There are a few drawbacks, and unfortunately, because still this is quite a change. So one thing that you will not be able to do because we thought it was too difficult to address this problem probably, is that we're not able to export the data from Esmont and to ingest it back into Elasticsearch. So that means that unless you keep both archive running at the same time, you will not be able with a new 5.0 installation to have all your perfSONAR historical data. So if you have a central management setup, that's probably the easiest. You can configure MatDash to access both the historical data that will still be stored in Esmont and the new data that will be available in Elasticsearch. But if you run a toolkit, your perfSONAR measurement history will be empty at the beginning. We will provide some way to still access the historical data, but you need to make to decide for yourself if you you want to install these optional packages and do the additional setups that it will require to access the historical data. That was too big a challenge development-wise and also process-wise to export the raw data and to ingest it again to Elasticsearch. In some situation, this measurement data is a few tenths of gigabyte. If you need to do it for a few perfSONAR hosts, that's going to take a lot of time and probably issues with migrating between the different formats. So we decided not to try to address this and not put too much effort into that, but instead giving you the possibility to access both in different ways. And 5.0 also comes with some new features that are not as that don't bring such a major change as the change in the backend. So you'll see new plugins for pScheduler and some improvements to pScheduler. There are also some changes in the toolkit UI that are coming up. The psconfig web admin has been changed quite a lot to and improve in many different ways. And you'll see some optional packages giving you access to SMON data and possibility to use Kibana as well.
So Antoine, can I ask questions as we go?
Yeah, sorry.
Can we ask questions as we go along, or would you like it at the end?
Yeah, maybe it's easier if we take all the question at the end.
No problem.
Yeah, sure. Thank you. And yeah, so that's
and there's the end.
yeah, that's the end of this presentation, and we can either take question now or go to the third presentation and take all the question after the third presentation. That the next one is by Tsotne and is on a different topic. So yeah,
my question's on what you said. So.
Yeah, so maybe it's better to address it directly as if it's related to this.
Yeah,
topic.
so I mean, you highlighted what the issue is there about the different backends. I think one of the big strengths of perfSONAR is being able to see the historical data and to view what's changed over time. So a straight cutover isn't going to be something many people will be happy with. So just to clarify, the suggestion is we run both backends for a period of time, visualizing off the current Esmond one, and then at some point you will have the Elasticsearch data and you can switch over to that when you're happy with whatever the duration is, if it's 3 months, 6 months, even a year. Is that what you're suggesting?
Probably in each case we'll need to see exactly how to set this up, but MatDash can be configured to have to access different archive at the same time. So with a single MatDash installation, you'll be able to see both the new measurement, the new data stored in Elasticsearch, and the old data being stored in Esmond. We'll discuss this more in details tomorrow, the different options that exist for the migration and to access the data.
Yeah, I think that's true. It's going to be a very common question in the fact, though, isn't it, as to how you have a persistent view when the backend's changing. All right, thanks, Antoine.
So I see in the chat there is a question from Renata and
Olaf. There is a question from Olaf about the Elmond, if it's going to be relaying to the old Esmond. Actually, I believe that's the point of that.
Yeah, so it depends what you mean by relaying, Olaf.
Yes,
so but Elmond will offer the same API to the outside world, the same Esmond API. So any tools that that are any tool that are using the Esmond API will continue to work using Almond, but the backend will be different. So the backend will be Elasticsearch.
Yeah, and the other question, just for the public, from Renata is about if it would be possible to collect the measurement results from the 5.0 deployment into a central host running, still running the 4.0. Well, actually, yeah, that shouldn't be a problem from my point of view. You are kind of breaking our work on on upgrading the system, but actually it should be possible. pScheduler will continue to support the old format to send the data. I'm not sure, Antoine, do you think it will break it? But yeah, Mark is here also can.
No, that should continue to work fine.
It's an archiver there, so yeah, it will be supported. It's just that you won't be able to make use of all the benefits of the Elasticsearch.
Yeah, and well, you'll need to tailor the setup of a new perfSONAR 5.0 toolkit, because by default it will use the HTTP archiver, but it will still, the Esmond archiver will still exist, and you can still set it up so that it sends the measurements to an old central measurement archive. Okay, so if there are no more questions, and I don't see any more in the chat, then I will hand over to Tsotne, who is going to talk about WiFiMon and perfSONAR running together.
Thanks, Antoine. Hello. Let me share the screen. Can you see the screen?
Yes.
Okay, thanks. Hello, everybody. I'm Tsotne Gozalishvili. I work as system administrator at GRENA, and also I'm participating in the two projects in perfSONAR and WiFiMon. My presentation today will cover both these projects, and also partially we'll cover the third one, the EduROM. With the personnel, most of the audience, today's audience, more or less is aware, and so I will start my presentation with the introduction to the WiFiMon. So what is WiFiMon? WiFiMon is a network monitoring system which can measure some different network, wireless network quality, and it can also visualize the different metrics, and this is the main use case for the WiFiMon. You can find more about WiFiMon at the wiki page at GÉANT.org. This is the key components. So you can see the key components of the WiFiMon. This is the wireless coverage area. Here we have some users. This is the wireless access point, and how WiFiMon operates. When clients visits the frequently visited websites, the small JavaScript code is inspected at that website, and this JavaScript code initializes the download of different web resources from the WiFiMon test server, which may be the virtual server, and it measures the download speed. It measures some kind of the other measurement, and then it sends the information, the measurement results back to the WiFiMon analysis servers. This process happens transparently and automatically and transparently to the clients. In the WiFiMon, besides the client devices, such as mobile phones, such as laptops and notebooks, often we use hardware probes. These hardware probes represent small devices which we put at the wireless coverage area. And they are used to permanently run different tasks. And also they measure the download speed, the quality of the wireless network, and they are also sending the measurement results back to the WiFiMon analysis servers. The role of hardware probes in our case includes the Raspberry Pi devices, Raspberry Pi 4 in our case, so these small devices. So we had several Raspberry Pi devices running WiFiMon, and we thought if we can extend the functionality of these devices, and we thought if we can install perfSONAR together with WiFiMon and run perfSONAR tasks together with the WiFiMon tasks. Then we started this installation and the testing process, and another idea got the area where these devices are located are under the coverage area of the eduroam network. So we decide to connect these devices to the eduroam network, and at the same time we decide to monitor the quality of the eduroam network also. So the fact is that our Raspberry Pi devices run the Raspbian operating system, which is Debian 10 based operating system. It is a lightweight and it is designed especially for this kind of device. It is designed especially for the Raspberry Pi device. As far as it is lightweight operating system, the graphical interface of the Raspbian OS, where you want to configure the network, different network options such as wireless user and wireless password, doesn't support an AAP option with the extended authentication protocol, which is necessary to connect to the eduroam network. So with graphical interface, it was unable to connect to the eduroam. And after some trouble and after some configuring with the command line interface, finally we were able to establish the connection to the eduroam. So to summarize some facts, we have the Raspberry Pi device running the Raspbian operating system. We have WiFiMon installed on it. Also, we have the perfSONAR installed on it. And these devices don't have much power. They have 8 GB of RAM and the 4 core of the CPU, 1 GB Ethernet port, and dedicated wireless adapter for the eduroam, to connect to the eduroam and to use with the WiFiMon service. So as far as these devices don't have much resources, so we think how can they share the one device, if the resources of this Raspberry Pi device will be enough to handle different tasks, and if the resources will enough to to start these two services at the same time. The architecture of scheduling tasks in perfSONAR is like this. The perfSONAR uses the pscheduler service, which is responsible to running tasks, which is responsible to put tasks in the correct order, and there is no possibility that at the same time there are two perfSONAR tasks running at the same time. But at the other hand, the WiFiMon uses the GRENA service, as you can see here in the screen. It uses the GRENA service to run its own tasks, and because we have two different services, because we have two different GRENA and pscheduler service, they operate differently, and there is a possibility of overlapping the tasks. And in case if two tasks will run at the same time, there we can be at the limit of the resource usage. So one possible solution for this is to have the WiFiMon plugin, which will handle also the WiFiMon tasks. As far as you can see here, that these tasks are the simple bash scripts. It's not very easy to provide such plugin. But we want to be sure if there is a need of such plugin, and also we want to be sure there will be a lack of resources in case if these two services will run at the same time. So we decide to deploy a resource usage monitoring, and for this purpose we use Prometheus. With Prometheus we collect different data from the Raspberry Pi device, and with Grafana then we visualize these collected metrics. You can see here the dashboard of the Grafana. Here you can see the system load is near to 0%. The RAM usage is very low. That's because we don't run any tests yet. And next steps will to run only perfSONAR for the first, to run only perfSONAR related tasks and see if there will be some and check the resource usage at the Grafana. And the next step will be to run perfSONAR and WiFiMon together and check and compare the results of the resource usage and see if the hardware resources will satisfy the need of these two services. So at the end, I can say that you can use the Ansible playbook. Both of these projects provide the Ansible playbooks for the clients. You can download them, and it's very easy to use. It's very well documented. You can use them to automate the whole process of the installation, the whole installation process. Links are here, and I think this presentation will be available. So thank you, and any questions?
Yeah, thank you for this presentation, Tsotne. Yes, we take any question on Tsotne presentation now? Or we can go back to other questions as well on the two presentations that I made before.
I see one question.
Yeah.
From Edward. Yes, there is a Ansible playbook, and you can use it to install the WiFiMon. I will put this link at just a moment. Here's the playbook. You can use it.
Is there some other questions? So another question is coming up for you, Tsotne. Is there a Docker image existing for WiFiMon?
No, not yet. There are people that they are working for the Dockerizing of the WiFiMon, but we don't work on this solution yet.
Hi, Marian. So welcome back, everyone, after the break. And here, for this second session today, we have 3 different talks, more related to the user experience from perfSONAR. So the first talk will be from Marian with an update on how perfSONAR is being used in the WLCG. Then a talk from Doug about their experience with high-speed testing in the EPOC group. And then a talk from Mark about perfSECURITY, so how perfSONAR and InfoSec intersect, and what's useful to say about it. So let's start right away with your presentation, Marian. So yes, you can go ahead and share your screen.
Okay, can you see?
Yes, that's good. Thank you.
Hi, everyone. So I'm Marian Babik. I'm a software engineer at the European Organization for Nuclear Research in Geneva. I've been working on WLCG perfSONAR infrastructure now for a number of years, together with Chown and Keith from University of Michigan, whom you might know. I guess he gave this talk at the last workshop. So I'm going to talk on behalf of the WLCG Network Throughput Working Group, which is the working group that organizes and supports WLCG perfSONAR activities within WLCG. I will cover general infrastructure updates and the evolution of the perfSONAR deployment in WLCG. I also have a few slides on the 100 gig mesh that we have set up recently, and some of the testing experiences that we do. Then I will talk about the Open Science Grid, and it's a common project between Open Science Grid and WLCG on the network monitoring platform. That's the platform that we use to collect, store, and visualize all perfSONAR data, together with other data that we have from storages and so on. And then at the end, I will talk about some of the new activities that we did in the area of analytics and tools. So moving on, WLCG perfSONAR infrastructure and our activities have been evolving around different projects. So there has been some funding coming from NSF, and which has been directed to the Open Science Grid. There has been also some funding coming from WLCG. So we have been working or relying on the perfSONAR team and perfSONAR consortium for the perfSONAR tool, but we do have within OSG a core networking group, which is funded by the NSF project IRIS-HEP. which runs the operation, support and coordination, and some DevOps for the monitoring platform. Then within WLCG, we have a throughput working group, which looks into the actual configuration and meshes, as well as following up with the issues. So it runs a second level support unit and triages the problems. And then we had two kind of R&D activities. One was NSF-funded SAN project, which primarily contributed to analytics, visualization, alarming, and alerting. And then we had the HAPIX network function virtualization, which was looking into more of an R&D. Well, that working group has ended. We still have now the flow and packet marking activities, so-called site tags, which are looking into being able to device monitoring information from the actual transfers and in general improving our visibility into our networks. So moving on, our current infrastructure has around 240 active perfSONAR instances spread around the world. I think a good subset of that is within the 2000 public perfSONARs that Antoine was showing in his presentation. We have around 207 production endpoints. These are both the so this is the sum of both latency and bandwidth nodes, since each site in WLCG is asked to run a dedicated latency and bandwidth nodes. All this infrastructure is maintained by the WLCG sites. So each WLCG site runs one or multiple perfSONAR nodes. We are relying on the PWA, on the perfSONAR configuration tool, to coordinate the testing and be able to configure the instances from a central place. We run a number of meshes, so we continuously test over 5,000 links, and our users are now not only the WLCG, so we now have all LHC experiments, Atlas, CMS, LHCb, and Alice, but we now also have other particle physics experiments such as Dune, Bell 2, and more recently we also have astrophysics LSST experiment, and then different projects. So LHCOP and LHC1, which is the networking project backing the networks for LHC, European project Archiver for backing up data to the commercial clouds, and then NSF-funded projects Toshcash, Slate, and CC Star are also using part of our infrastructure of tools. So we have a quite diverse deployment from the 238 active instances. We have a range of different hardware and software resources deployed. As you can imagine, most of our perfSONAR nodes have, the bandwidth nodes are usually 10 gig, but we now have a quite interesting chunk of 100 gig instances. About 10% is now 100 gig capable. The latency nodes usually use 1 gig. And as you can see, 80% of the infrastructure now runs the latest perfSONAR release. But we have all the scale back to 4.0.2. So for some reason, the 80-20 rule here works quite well. In terms of evolution, I think we have been quite stable. So the actual numbers are not increasing. So the number of sites in WLCG did not increase. So this is correlated. We have been asking our sites to improve the hardware as possible, and we have some regions, like for example UK, where most of the sites have been upgraded to latest firmware and are now also deploying 100 gig capable boxes. We also had very good feedback from most of our tier 1 sites, so that's the biggest sites that are in WLCG. But we also have some tail with the smaller sites where the actual toolkit deployment might be quite heavyweight. for them. Concerning 100 gig testing, so this is our mesh. So as you can see, we have around 10 sites that participate. We have the University of Michigan, Brookhaven National Laboratory, CERN, Karlsruhe Institute of Technology. We have Triumph in Canada. In UK, we have Imperial College and Queen Mary. Now we have University of Nebraska, and then we have LCG Center in Prague, all running 100 gig capable perfSONARs. You can see that we have updated the thresholds, and our overall aim for 100 gig mesh was to achieve at least 10%. So far we are not there, but the overall status of the meshes has improved, and we are now seeing consistently quite good results with very few links, although we still see some of the links not performing as we would expect. We have had a couple of meetings since January on this, and have been mostly discussing the ways how to tune the nodes. We have been following the ESNet guide, and we use the CheckMK monitoring, which monitors our infrastructure, and the Elasticsearch Kibana dashboards, the one you have seen already, to check and follow up on the status. I think most of the issues that we had were resolved by increasing the TCP buffers and fixing MTUs, because the defaults were quite low. We also tried fair queuing, but that actually decreased the throughput. So we reverted back, and we also looked into tuning up interrupts and core sync with the NICs. However, this is somewhat challenging with the PWA, because there is no easy way to configure which core or NUMA core should be used when configuring in PWA. Even if there are still too many options if you have multiple sites. One of the other things that we looked at was in MadDash, we have tried to extend the time window that is used for the averaging of the throughputs, because we see some sites where performance jumps up and down. This could be because most of the WLCG perfSONARs are installed actually are collocated with the storages. So they're usually deep within the site network infrastructure. So whenever the site is heavily loaded, this can actually have quite an impact. We also set up new host-based Grafana dashboards for the purpose of being able to follow up with 100 gig hosts. This is a Grafana dashboard that shows everything that we currently measure. So on the left column, you can see CERN to Brookhaven. So the first graph is on latency with the red one, with the bright green. You can see the latency. CERN to Brookhaven with the dark green. So the bottom part is the reverse direction, Brookhaven to CERN, and the red part is the corresponding loss that you see on the link. Then the second graph has the throughputs, with the red dots being the retransmits, and the last one is the round trip time and hops, which are coming from the trace routes. So we have the same thing for both IPv4 and IPv6, because we are running both IPv4 and IPv6 throughputs. We do use the dual stack latency, so most of our latencies are IPv6 only. This is mainly to save the resources, because latency testing is quite heavy. As you can see on the graph for CERN to Brookhaven, we are able to achieve consistently above 10 gig, which was our aim, but in the reverse direction, you see that this actually jumps up and down sometimes, and it depends. So for the Karlsruhe Institute of Technology, you can see that the results are not as good, despite the fact that this is a lot closer to CERN than Brookhaven. So we have been looking into these sort of issues, and it has been quite an interesting experience so far. So apart from 100 gig testing, we are also looking into operating and deploying our network measurement platform. So this is the platform that collects, stores, configures, and transports all the perfSONAR measurements that we are taking. This is organized as a distributed deployment. So there are different components deployed at different sites. We are using, so starting from the left, we are using the perfSONAR configuration tool PWA to configure all our perfSONAR instances. We have checkmk based monitoring to actually check if all perfSONARs run correctly and how efficient they are in measuring what they're supposed to measure. We are using MadDash, and then we have some quite complex component called collector, which actually pulls results from the toolkits on a regular basis and then submits them to a message bus. We are operating 2 message buses, RapidMQ and ActiveMQ. And then we have a set of long-term and short-term storages. The long-term also has a backup to tape. So when there is an incident, we have a possibility to replay the results from the tape back into Elasticsearch. And then we also have a monitor Grafana instance, which you have seen already. We have also other dashboard, not just the host-based one, but that one is quite interesting. So with perfSONAR 5, we have been now looking into evolving this this platform to better reflect the developments that are ongoing within perfSONAR, and we would like to mainly work on the collector and change the way results are being fetched from the toolkit. So we would like to rely now on the HTTP archiver to send the data directly from the toolkits to the Elasticsearch, to the central Elasticsearch in University of Chicago. We currently run some experiments to see if this would actually be feasible on a global scale. But we have some other applications in WLCG which are doing something similar where it works. So we are quite optimistic that this would be possible. We would still need to run collector to pull the results, either in case the HTTP archiver is not working or during the transition period, but also we also have some perfSONAR toolkits that we don't control. So we will not be able to configure HTTP archiver on it. So we would still need to pull. So with some minor changes, the rest of the chain would stay the same. The only difference is that we are also working on having an improved topology information. This is the information that maps different perfSONAR toolkits to sites, because we are running for different experiments and different experiments are using different site names. So we have a topological tool, but the topological tool is also interesting from the perspective that it actually can capture which subnets, which ASNs correspond to different sites, so we can actually do a bit of a validation. And then we have the new alarm and alerts service, which is part of the analytics. So apart from this, since we have quite a lot of different resources, we now have a new homepage, which is publicly accessible and actually shows all the different links that we have. We have been also playing with the Kibana dashboards, not just Grafana, and we have dedicated dashboards looking at bandwidth, traceroute, packet loss latency, and the infrastructure. That's the one you have seen. However, there we have a mixed experience in what can be achieved. Some of the things seem to work better in Grafana than in Kibana, but overall, we are looking into ways to better visualize our data, because this is quite critical. And then we have spent quite a lot of effort to try to analyze our data in different analytical projects. One of the first tasks that we had to do was actually cleaning up perfSONAR measurements, because as you know, there can be quite a lot of noise in the measurements. So the first step that we did was actually try to correlate the data that we have from the monitoring on the status of perfSONAR toolkits with the actual measurements, and have been trying to clean up the data that we know are not valid. So things like negative latencies, 100% packet loss, and etc. And we have set up a dashboard as part of this. As part of this work, there was a dashboard set up which actually summarizes some of those things. And then for the alarm and alerts, so from that dashboard and the actual backend which runs in, there is a connected Kubernetes cluster to the Elasticsearch, which can run analytical jobs. We are able to issue alarms on the different events that can happen. So we have two types of events. We have the infrastructure events, where we are looking for bad one-way latency measurements or complete packet loss, firewall issues, large clock corrections, not by looking at the toolkit itself, but by looking at either the monitoring data or correlation of monitoring data and the measurements. And now we also have some actual network alerts like bandwidth increases, decreases from to multiple sites. And we also have some network path changes work ongoing. So for the bandwidth alarms, we are...
Marian, if you can, just 2 minutes maybe remaining.
Yeah, I have 2 slides. Okay, so the bandwidth alarms detect changes in measured throughput with respect to 21-day average and are able to issue an alert whenever this goes below a threshold. So as you can see, then there are emails like this where you can see that the throughput has decreased from one site to a number of different sites, and there are changes in percentages. And the other analytical work that we are doing is actually from the trace routes. We are trying to detect changes in ASN sequences. So we take the trace route measurements, which is transformed into an ASN sequence, and then we are looking for the changes in the ASN sequences. This has been very interesting work because there is also a need to take into account multiple different network paths, and being able to detect the changes has been quite challenging. But we have progressed quite a lot on this, and now we are actually seeing quite a lot of interesting alerts from this. So in conclusion, OSG in collaboration with WLCG operate quite comprehensive network monitoring platform. We have been with perfSONAR community for a long time, and I believe we also have contributed, but also provided quite a lot of feedback to the community on different aspects of perfSONAR. We have been very happy in using this, and we are currently trying to push it even further with developing some high-level services. That is all from my side. Sorry if I extended.
No, that's fine. Thank you, Marian. Is there? We can maybe take some quick question now during 5 minutes, and then another set of questions at the end if time remains.
If no one else is asking, I'll throw a quick one in. You mentioned negative latencies, maybe on short paths. What sort of accuracies are you seeing with NTP-based synchronization? It's a topic that's come up elsewhere. Presumably, you're talking about the one-way delay measurements.
Yes. So in one-way delay is quite sensitive to NTP, and we have regions where the configuration of NTP is not optimal. So there are countries where they rely on just few NTP servers, and there we see that they often have issues with clocks, and then this actually causes negative latency. But as far as I know, we are also now looking, I think Chown has an experiment with the satellite clock. So that's the other protocol is.
Well, there's PTP, but
Yeah,
that's
it's
not
PTP.
satellite.
Yeah.
Oh, is
PTP.
it?
We
Okay.
also did some experiments with PTP, but so far we had limited success.
That was going to be my follow-up question. You stole.
There are quite a lot of, Chown had quite a lot of issues. So I was also looking at this because we also have a PTP clog at CERN, but we didn't manage to progress much so far.
Maybe this is something to pick up in the perfSONAR beyond the 5.0 discussion tomorrow. But yeah, I mean, my experience is looking at perfSONAR measurements in both directions. Usually the synchronization was in a good configured network is within a millisecond or two. Sometimes you don't even notice it. But I think you make a good point that if the perfSONAR node is deployed somewhere that's on a poor connection, a congested connection, or even one that has NTP servers that are not optimal, then it may well drift somewhat higher. The PTP is interesting. There's a holding statement on one of the perfSONAR website pages. Maybe probably Mark knows that. It's probably better than anyone. And it says something like it's expensive to do, too much effort, not looking at it yet. But maybe it's something that might be revisited, because I know there's a handful of NRENs that are starting to make it available and deploy it. And I think we've had some conversations with MPL in the UK, for example. So it's maybe something we can look at.
Tim, I'm on a same name basis with the guy who wrote that statement. So,
he's called Mark as well.
Yeah, he is, strangely enough.
Oh, really?
Yeah, no, I mean, and we wrote that statement, God, probably 5 or 6 years ago. I think it was probably 15 or 16 when we wrote it. And at the time, I mean, things were a little different. My take on it, I mentioned this in the chat, is that, I mean, PTP is great if you have the infrastructure for it. My take on it is that rather than try to discipline the system clock with it, it would probably be better to develop latency measurement tools that can use it directly by tagging the packets as they go out, and then picking that up on the other end and comparing it, because you'll get a much more
that's the sort of thing it's the sort of thing Maro's been doing with int, for example. But there are advantages and disadvantages to int, but int is one promising way you could do that, or even fireflies, who knows. Okay, thanks very much. Yeah, I'll bring up PTP again tomorrow and maybe talk a bit more about it.
Right, thank you. Well, thank you for these questions and comments. And we'll now go over to the next presentation from Doug at the Indiana University. I will directly hand over to him.
All righty, just inadvertently closed PowerPoint, but looks like I got it back. Go ahead and share this. Well, thank you. Appreciate the time here. And some of what we're going to talk about today is going to be a little bit of a rehash of some of the things we've already talked about, but just some guidelines that we stick to when as EPOC, we're talking to other people about what to expect from high-speed testing, what to, kind of hardware specs, and just general trying to set user expectations when they start delving into either 40 gig or 100 gig testing, because it's not terribly straightforward at times. It can be a little bit tricky. So just we'll take a brief walk through some hardware considerations. And again, these are very, very general, at least guidelines to get you started. Obviously, there's much deeper discussions to be had if you're really getting into specific performance tuning. But one thing that gets overlooked a lot is that clock rate still matters, especially for 40 gig and 100 gig testing. Any modern CPU can cope with 10 gig testing. Pretty much any CPU period can cope with 1 gig. But bits still have to make it between RAM and the NIC, and the bridge for that is the CPU. So people typically ask if they're setting up a new node. Well, I've got a multi-core processor though. Well, the problem is TCP streams are single threaded, so you need a core. So if you're doing multi TCP testing, you're going to need multiple cores, but the clock rate of each individual core matters. And what we've found in general is if you're going to do a 40 gig test, you probably need 3 gigahertz per core. And if you're trying to push 100 gig, more than that is necessary. Again, almost anything else will cope with 10 gig or so. You're going to need enough physical cores to handle the anticipated number of parallel streams you're going to be doing. And you need physical cores, not hyper-threaded. These are going to be dedicated, hard-working CPU cores when they're pushed to their max for this kind of testing. So some general guidelines that sometimes get overlooked, but this becomes more necessary as we're trying to do these higher speed tests. Typically don't need a ton of RAM, but the consideration that gets overlooked a lot is how to populate slots. And this gets a little bit trickier when you're talking about multi CPU systems, especially when you're talking about NUMA boundaries, stuff like that. But in general, guidelines that we give are you're going to want to try and occupy every RAM slot on the board. So in practice, that means using smaller modules in quantity as opposed to using larger modules and not having everything occupied. This is there's a lot of different effects, but effectively you're going to be maximizing the amount of bandwidth you have between RAM and the processor. This is probably going to result in a moderate system. You're going to have more RAM on board than you technically need for what your perfSONAR node or your DTN is doing. But the goal here again is high speed, not just about capacity. So on paper, it may look like it's over provisioned in this regard, but we're trying to do something very specific, which is create the highest speed transfer system that we can possibly get. Storage questions are kind of out of bounds for the kind of testing we're doing, but it still comes up fairly often. There's nothing on the market, that you're going to put into a 1U pizza box that's going to cope with disk-to-disk transfers. At 100 gig, you're talking 12,500 megabytes per second. So storage in this context is, of course, talking about maybe storing results. But we're not really looking at disk to disk as such. We're doing network testing, not disk testing. So I usually try and steer people away from that. I mean, we've gotten into design discussions where they're doing testing between a large, a Lustre file system, or, they've got a DTN or a node that's Ethernet in the front and InfiniBand out the back to some huge disk subsystem. But those are really kind of outside the scope of most of the type of testing that we're looking at doing. And so we kind of caution people, don't let scope creep when you're talking about storage dominate your purchase decision. We're interested in a very specific set of resources that are going to do network testing, not disk testing. So on the OS side of things, Linux, Windows, whatever platform you're on by default aren't tuned particularly well for these kinds of speeds. So there's going to be some things in the background that are going to happen. Again, 10 gig testing it'll cope with. 40 and 100 gig, not as much. One of the things we run into consistently is still MTU mismatches. Of course, the goal is to have a full path, if possible, that is 9,000 MTU end to end, but that requires the path to respect that at every single stage, and you're not in control necessarily of every piece of the network, even on your own campus, let alone all the pieces and parts of networks in between if you're doing a long distance transfer. So at a minimum, we're trying to make sure that path MTU discovery is healthy, so that if it needs to step down to MTU of 1500, it can do that cleanly. The packets are fragmented the way they're supposed to be, because that has a huge effect on performance. But even if that is all working, there's still going to be a performance cost if we're having to fragment packets. So ideally, working with network providers to make sure that the path is 9,000 end to end is the perfect scenario, but sometimes that's not always possible. Getting deeper into the system and tuning window sizes, TCP buffers, because by default, those are not large enough. I think Linux by default is at 64 megs for the TCP buffer. Want to turn that up to around the maximum of 2 gig if possible. You can get even deeper in, specifically tuning ring buffers. All these things, as you're tweaking and tuning, are necessary if you want to see performance that's going to be close to 40 or 100 gig. One of the things we run across fairly often is people standing up a brand new 100 gig node. They haven't done any tuning. They just installed perfSONAR. and they're disappointed to see that they're getting less than 10 gig through it, or even in a back-to-back test in a lab where there's almost no latency, they still aren't getting more than about 20 to 22 gig. This is one of the paths we usually lead them down, is understanding what these settings do, and that tuning is sometimes a trial and error thing. We can give baselines, we can give general ideas, but it's a little bit of an art at times. And so some trial and error and playing around to see what works best for your specific setup and the latency of the transfers that you're doing. A lot of times that's necessary. So one kind of use case we had for this was the Arecibo telescope. So they had 20 plus years of absolutely irreplaceable data, and we needed to get out of there fast as possible, because the situation there was a little tenuous, and some of the data, they were the, actually most of the data was the golden copy. It was the only one that existed. So we ended up using a couple of Synology NAS units. They were 1 gig on board. They had a slot where we could throw a 10 gig card in it. We did that, but the initial results weren't better than, honestly, about the 1 gig interface. So we went in and we did some of the tuning we just talked about. And we ended up getting about 4 gigs out of them, but then we found out we were actually limited by CPU speed. We didn't have enough clock cycles to push more than that. But still, it made a huge, huge difference when we were talking about petabytes of data that need to be transferred to be able to get even those kind of speeds versus sub 1 gig speeds. So tuning, definitely very important if you're doing high speed testing or any kind of high speed transfers. In terms of network architecture, we still run into shallow buffer switches quite a bit. Just because it's a 100 gig switch doesn't mean that it's going to be performant over a long path. So understanding that if you're doing 100 gig testing across your data center with sub 1 millisecond latencies, almost any switch that says it'll do 100 gig will probably do 100 gig, but the bandwidth delay product of 100 gig transfer is massive. Over a 50 millisecond hop, you need 600 megs worth of buffer if you're going to get 100 gig. Obviously that scales out from there. And understanding too that just buying a deep buffered switch isn't necessarily good for every use case that you're going to have. At times, we have to look at, we'll talk a little bit about this later, some network architecting where certain transfers have to take a certain path through certain hardware, because having deep buffers like that can be detrimental to performance on other kinds of traffic. So networks aren't one size fits all, and the placement of 100 gig perfSONAR node is really, really critical when it comes to trying to understand what you want to test and what segment of your network you want to test and how your network is configured, what your use case is. So those are some considerations we try and lead people through, is understanding what they actually are wanting to test for versus just saying, we have a 100 gig pipe, we want to know if it'll do 100 gig. Well, it depends is kind of the answer. We need to look a little deeper than that. Firewalls and unified threat management devices, man, a lot of times these hamper performance. They're necessary for enterprise style networks. They have their place, but again, like anything else, when you're talking high performance, now you've got to do some planning. Just throwing a firewall in your network doesn't mean that there's necessarily, security without specific tuning. Also, removing a firewall from a segment of your network doesn't mean that it's vulnerable. As long as it's planned and there's some common sense ACLs in place and you've got test limits in place, understanding, again, that you're trying to do high-speed transfers, you need to know what kind of equipment you're going through and what effect that's going to have on performance and what that equipment was designed to cope with versus what you're trying to do. So again, it all comes down to planning, understanding what the hardware is actually capable of and what goals you're trying to achieve. And so that dovetails into one thing we talk a lot about, which is the science DMZ, the concept of splitting off your performant high-speed traffic into a different path from your typical enterprise traffic. So your enterprise traffic still goes through the your border router, it goes through your firewall, maybe goes through whatever security devices you need because it's going everywhere in the world and you don't necessarily know every endpoint. Whereas on the Science DMZ side of things, you now have a path that maybe goes through different switch gear that has the deep buffers that are necessary for high-speed transfers, and has a very restrictive set of ACLs where we know that we're only doing business with these specific partners. So those are the only ones that can get into this side of the network. You don't have to leave it open to the world at large. The other side of it too is understanding that the Science DMZ is not a network where you have printers. It's not a network where you have user machines that are going to be browsing the internet in general. So understanding how those devices are going to be used and creating an appropriate network path for them is absolutely critical when you're talking about high-speed testing and trying to vet out a large high-capacity circuit like that. So just some general things to think about. I didn't have a ton of content here on this talk because I wanted to leave some time open for questions and answers if possible. But useful metrics that sometimes get overlooked, at least in the early stages of testing, we're just looking at bandwidth, but packet loss is a big one that we run into. Again, when we're talking high bandwidth delay products because of large amounts of bandwidth, we're trying to get to as close to zero as possible. In the commercial world, a fair amount of packet loss is acceptable because typically resources are close. We have content delivery networks. You know, if you're watching Netflix, the content that you're watching is not on the other side of the globe. It's typically somewhere fairly close to you. So you can still get reasonable performance even with a fair amount of packet loss. A lot of what we're looking at when we're doing this high-speed testing to remote science facilities is we need a network that literally functions perfectly. That's almost impossible in the real world, but it's the goal we're trying to get to. So bandwidth only tells you part of the story. It's bandwidth in conjunction with, you know, packet loss and latency, whether it's a quote unquote local resource or whether it's something that's 200 milliseconds away is going to have a huge difference on what the performance looks like. We take into account latency and routing. Is there a more direct path? Can we get that latency lower? Or conversely, is there a path that may be higher latency and on paper it doesn't look as good, but it's actually a cleaner path? Is that one we should explore? So when we're doing testing, sometimes we look at routing changes that maybe don't make sense in terms of lower latency, but the goal is the maximum amount of throughput. And even watching latency, have there been changes? You know, if you're used to seeing a 38 millisecond latency kind of consistently and all of a sudden it's 55, keeping an eye on those kind of changes and how they affect your performance is something useful to watch. So while the bandwidth meshes usually get a lot of attention, we try and get people to understand and take a look at the other metrics that go into this and how they play into what kind of performance they're experiencing. So 100 gig single stream transfers, not something we see outside of testing. So we're trying to do those. We're trying to look out there and see what we can push through a single stream. But depending on the application, maybe that doesn't make a ton of sense. Maybe we want to look at 10 gig, but we're going to do multiple streams at 10 gig to see what performance looks like on that larger link. And that in part is because in a lot of the work that EPOC does, the goal is to model end user performance expectations. It's not necessarily just to try and cram as much bandwidth down the pipe as we possibly can. So if we want to model that, it's pretty rare that we're going to have a researcher doing a 100 gig single stream. So we tend to look at the process a little more holistically in terms of how the network is going to be used, what the end user expectations are, and set up testing accordingly. Obviously, participation in a mesh is something that's helpful, helps you track performance over time, helps you keep an eye on what things are doing and maybe make improvements, but again, only if that's monitored. Marian talked about setting useful thresholds and alarms on the mesh, and that is incredibly important. If you set thresholds that are unrealistic and the mesh is always green, that's not useful. If the mesh is always in alarm, if it's always, you know, red or orange or whatever your alarm color is, also not useful. What you want to be able to see is changes in performance that catch your eye. So if you have a normal baseline, maybe taking a look at keeping an eye on that, where if it's changing over time, or all of a sudden one day that this has been a stable, you know, we'll call it a green link, is now something else. Why is that the case? Something you can delve into. And so sometimes that means maybe breaking down into smaller meshes, where if you know that a certain set of 100 gig nodes are never going to achieve a specific bandwidth, maybe those 100 gig nodes, because of their maybe physical proximity or lack thereof to each other, go in one mesh, and then some other nodes that typically perform better go in another mesh. So you don't necessarily have one large mesh of nodes that are all performing wildly differently. Maybe you try and group those a little bit more so that you can see changes in performance and it doesn't get ignored. Human networking, last thing I want to touch on, just the idea of where do you find like-minded people. So if you are wanting to do high performance testing, you're not on your own. The routing working group is honestly a decent place to get involved if you're not already. Now, as the name would lead you to guess, the routing working group is something that's basically focused on routing efficiency, but there's a huge overlap with people in that community that are interested in high performance transfers, high speed testing. Conferences, I honestly always try and strike up hallway conversations when my ears perk up that somebody's standing up a new perfSONAR node or their brand new high speed DTN, and they're having problems with it. Sometimes just that human connection of getting, you know, together over dinner or something like that to establish a relationship with somebody who wants to work back and forth with you, rather than just dropping a node in a mesh and letting it exist there. They want to tweak and they want to tune. And so having a relationship with somebody that is willing to do that work on their side with you is really valuable when you're trying to optimize a host. One other thing we typically look for in EPOC is who are your partners that you're doing a lot of transfers with. You might be using perfSONAR to participate in a mesh, but you've got a researcher on your campus or your institution that is doing a lot of transfers with somebody who isn't represented in that mesh. So maybe that's a place to look at, because now again, you can model real world performance for that researcher and get a different look at what your performance looks like outside of a test bed. Now it's something that's actually, you know, quote unquote production traffic. So sometimes just finding out who you do a lot of business with gets you some buy-in, where if you want to do tuning, you want to do testing, you've got somebody with actual skin in the game, as they say, where they have a vested interest in improving that network path because there's actual production data going across it as well. One other thing.
Doug, just, 2 minutes remaining, please.
Last slide.
Yeah. Perfect.
So the data mobility exhibition is another place that is good to connect with people. So the DME is focused on more disk-to-disk transfers. This is DTNs and modeling, again, real world performance. What does it look like when we're doing a transfer between my DTN and this other resource? But they're very well-tuned resources. There are perfSONAR nodes in play with the DME. And a lot of the lessons learned from the Faster Data website that talk about performance tuning are put into place here. So it's a group of people who are interested in measurement and monitoring and optimizing network paths for data transfers. So if you haven't heard of the DME or have any interest in participating, I would really encourage you to check that out. Great community of people, again, that want to invest in high-speed testing, 40 gig and beyond, and understand how to really optimize their networks for that. So that's what I've got.
Thank you very much, Doug. Is there any quick question to Doug? There was some in the chat, some discussion going on in the chat.
There was a lot of discussion. The trouble is with Doug's talk, they're all so good. They raise loads of questions and make you think. Damn you. So one of the things you mentioned was the 9K MTU. What's the current view on how practical it is to run 9K MTU widely at the moment? I'm not sure how many, for example, of those 200 perfSONAR nodes in the WLCG run 9K MTU, or I think most of them in Marian's 100 gig mesh do. But what's the thinking on that at the moment?
In general, we're running into most nodes that are designed for 40 gig, even 10 gig on up. We're finding people very open to having them running at 9K and being able to do so end to end. Where we've run into some interesting issues is hybrid campuses where the main production environment for the campus is 1500 MTU, and even in their science DMZ, they want to keep it that way. But we've been able to, and so where they're trying to make that change is have their upstream provider make that change for them, where they are only receiving MTU 1500 from their provider. What we're encouraging people to do is you can change that at any routed hop. So might as well change that at your router. If you can get the path at 9,000 from your provider, whether that's Internet 2 or whoever you're connected to, whoever your REN is, do so. And then you've got the option to split that off. You've got the option to say, I'm going to continue that 9,000 path for my small science DMZ, but I can make a change when it jumps over to my enterprise network. You can make that change at a routed hop and still maintain that MTU of 1500. The problem occurs a lot of times when the network provider is providing that without the campus level people understanding that that's what's being provided. And that's where we're running into MTU mismatches, is at that interface where they're saying, look, I just want this, so I'm going to set my interface up for it, and not understanding the dynamics of where that MTU actually needs to be changed. So a lot of my work revolves around finding those kinds of problems and working with network engineers to say, hey, I understand why you want it this way. There's a couple of small engineering changes that we can make that will get you what you want, but make it a lot more performant than what it is. So.
Okay. Is that anything else in chat, Antoine? If not, I can throw another one in if there's time.
No, I don't see any new question directly.
Sorry, I've just got one observation to share. I wasn't sure if perfSONAR generally does path MTU or not. Probably it doesn't, but one of the observations I found while running tests is that if one of the node is sitting at 9,000, but the other node where the tests are being run to is 1500, the results are not reliable. It somehow, they're skewed a little bit, but I wasn't able to make sense of them until I then changed my MTU to 1500 on my box, and then the results were more understandable and better. So while I think it seems to be from Doug's presentation, there's a drive and it's better to be at 9,000. If the other node is not, I don't know the impact it'll have on the results and how you would understand them.
No, that's a very, very good point. And that goes back to understanding, when I was talking about understanding the network path you're on, understanding your configuration and the one on the other side. And part of that is having path MTU discovery working, making sure that ICMP is responding the way that it should be, so that if there is an MTU change, you get the error messages back, and the network can, perfSONAR, the rest of the network can figure out where that change needs to happen. perfSONAR doesn't currently do a preliminary MTU sizing test. I know that's coming out in version 5, but even perfSONAR, the current version, part of the reason you see the disparity there is perfSONAR is smart enough to figure out a common MTU if path MTU discovery is broken, but what you end up with is several hops of I got nothing, I got nothing, I got nothing, and then that gets averaged into, say, a 10-second test or a 30-second test, where the first 5 or 6 instances is perfSONAR sending no data, trying to figure out an MTU that it can work with. And then once it finds one, you start to get a valid test result. So that does skew results while that process is happening.
So I just want to, sorry, real quick. I just want to clarify a couple things that have been said and that are in chat that just I'm worried will confuse people. So first of all, throughput tests, we don't currently first run like a separate MTU test like in perfSONAR. You'll basically just do whatever the OS does. So as Doug said, if MTU discovery is working, iPerf or whatever you're running underneath the hood will work accordingly, which is what we want, right? Because we want to match what the end user is doing. They're not running a special MTU, you know, their tools likely aren't running a special MTU test beyond, again, what the OS does, right? So that's the desired behavior. And then what I think Mark and Ed are mentioning in chat is we want to add a standalone MTU test. Now you can actually get MTU out of multiple of the tools we already support, right? We support a whole range of tools. So trace path and things like that, you can get MTU out of and extract that information. But we don't have a P scheduler task MTU, right? That explicitly kind of grabs that. So that's something we're looking at.
Yes, but also you could run the pscheduler troubleshoot command against another node.
That's yet another way to do it. Yeah, I mean, there's multiple ways to do it. Yeah. So that was the point I was trying to make. Is MTU is in there multiple ways if you look hard enough, but what we're adding is explicitly tests to do that. So
which is incredibly helpful and appreciated.
All right, thank you very much for all the comments and questions. Yeah, to go on and keep with the agenda timing, I think we can close this doc presentation and hand over to Mark for the perfSECURITY talk. And if there remains more time at the end of this session, we'll take more questions.
Thanks, Antoine. Give me just a minute here to find the window with the presentation. Is that visible to everybody?
Yep. Well,
okay.
It says you've started sharing. Hang on.
Yeah.
Yeah, I don't see anything yet though.
Okay.
Maybe your MTU is wrong.
No, I know it's
maybe that was a trick question.
No, this is Zoom being a little cantankerous. Give me just a second here. Try to do it the right way and it just doesn't want to cooperate. There we go. Let's give that a shot.
Yeah, you should turn the camera, your camera, towards the screen, and then we'll.
Yeah, let's do that. That would be sort of the old way. Okay, well, this is not behaving, so I will just do it I'll do it the old-fashioned way. Sorry, this is going to take. Oh, sorry, we are having some technical difficulties here. My screen just went completely black. So bear with me for just a minute.
We were seeing the same thing, something completely black. So perhaps.
Yeah. It's like Monty Python, and now for something completely black. Okay, let's give this another shot. I usually try to be prepared, but here we go. All right, is that visible to everyone?
It is, yes.
Okay, cool, good. So I will apologize in advance. I'm working through a little bit of a cough here, so I may have to pause and cover that in the middle of this someplace. So I'm Mark Feit from Internet 2. I also make my living working on the perfSONAR development team. Some of you know me, I think many of you do, but hello anyway to those of you who don't. This presentation is called perfSECURITY, and it's something that was originally written and kind of directed toward information security professionals who don't necessarily have a lot of knowledge about perfSONAR. Since I think most of you already know what perfSONAR is, the agenda today kind of we skip over that stuff because I figured it would be kind of repetitive. There are a few things you will probably have already seen in this as well. But so the two major topics we're going to cover today are information security for perfSONAR and perfSONAR for information security. So let's dive right into the first one, which is just sort of what security looks like in perfSONAR and what information security organizations can add to it. Generally speaking, the way we handle security is kind of we try to do sort of the standard, the standard accepted good things, I guess. So we do things like have our installation bundles only install and run the necessary services. Host firewalls are locked down just to the required ports. We have a limited requirement for user accounts. That was actually one of the design features actually in pscheduler, was that we didn't want to have users have to have accounts on the machines. They could just task it remotely. Pretty much everything that perfSONAR does is done with HTTPS. We don't require signed certificates for reasons I won't go into in the future. We may make that something configurable in a future release if there's demand for it. There hasn't been yet, so we haven't really bothered to look at that too much. We make regular review of what ciphers are allowed to be used, and we change those, just sort of with the changing landscape, and we put revisions to that in feature or bug fix releases as they come out. The security related upgrades to applications happen automatically, either through the operating system distribution, or as we release new changes and fixes. And I'll pat the teams. I'll pat the team on the back a little bit. We have a habit of getting vulnerabilities patched within hours to days of us finding out what they are. We mostly lean toward the hours end if it's not something that requires a whole lot of development. I'm going to review a little bit of terminology here. I'll blow through this pretty quickly, I think, because I think most of the people on the call here probably understand this already. pscheduler has this notion of a task, which is a job that you give it to do. So, for example, measure UDP throughput at a certain rate between 2 points. A run is a single execution of that measurement. Every task has at least one. Some tasks where you say, I want to do this, once an hour, we'll have more than one. Another term that we have is participant, and that refers to a perfSONAR node that is actively participating in a measurement. So most tests have one participant, and the two most famous for that are round trip time and latency. For round trip time, we just do that with ping, and basically the reason it's a one participant test is that the other end is kind of passive. It doesn't have to have perfSONAR installed, and it's it sort of participates by virtue of the fact that it has a TCP stack, but nothing else. Latency, again, is sort of the same thing. We use either the OWAMP or the TWAMP protocols. Client runs on the perfSONAR node, and the other end just has to have the service running. This is a service that we install in the perfSONAR as part of the perfSONAR bundles, and there are some routers and switches that have TWAMP services built in, so you can use them as destinations as well. Some of our other measurements, notably throughput, have two participants, and those require, for example, for just about all of the throughput tools that we have, require explicitly a client and a server, one at each end, with a perfSONAR node being a participant in that. Oops, sorry, hang on, having some more difficulties here. So pscheduler has kind of has a trust model built in. The first participant, or we call it the lead participant in all tests, which is the thing that oversees all the measurement and gathering the results and so forth. In order for it to do anything, it has to trust the requester. So it has to have something in it that says, yeah, this requester is okay. We'll do his measurement, or, and it may be a selective thing. I'll talk about that in a little bit, as far as, do we do certain measurements, but not others. It also makes requests of other participants if there are any. So in cases like throughput, where you have multiple participants, the other participants have to trust the lead participant the same way that the lead participant might trust the original requester for the measurement. So there's sort of this transitive thing in that other participants trust the requester if they trust the lead's judgment on it. So that's kind of an important point. We have a bunch of access controls built in. To begin with, all of pscheduler operates through a single REST API. So the command line tools, psconfig, or any third-party applications that people develop, all go through the same, all kind of go in through the same door. The API itself is mostly open. You can do things like, ask pscheduler, what are you doing? What were you doing? What are you going to do in the future? What were the results of measurements? Certain operations are restricted based on the originator's IP or an originator provided key. And that's for doing things like canceling measurements and so forth. We don't want anyone out on the internet just to be able to say, oh, there's a measurement, I'm gonna cancel it. Because that's obviously not something that's particularly desirable. there is a certain amount of information in the system that's considered confidential. Might be things like authentication keys for archiving, that sort of thing. And all of that is withheld on read. We have an internal mechanism inside of the API that takes any JSON object pair that has a key that begins with an underscore and scrubs it out on the way out. It's applied globally at the very end, just before a result comes out, so that there's no opportunity for any of that to slip out of the system. Testing itself is regulated by a thing called the limit system, and we've done some YouTube talks on that, which I'll cover in a second. But there are kind of four major categories to what we do with the limit system. The first is determining who is asking, and that's through identification and classification. I'll talk to all these separately in a minute. We can impose restrictions on what tasks are written or are executed, and that's through limits and applications. We have a thing that will apply changes to a task before we make any of these decisions. That's called rewriting. And finally, we have assignment of priority, which is called prioritization. The gory details of all of this are on. We have a couple of presentations on YouTube under the heading of Know Your Limits that talk about how to use the limit system in general. And we have an addendum that we did, I think, a year or two after the first one to cover some new features in it. The way the limit system is configured, there's a file that goes in the file system. If you just install pscheduler, there are no limits by default installed, and anything goes. If you install one of our bundles, you get a limit configuration that has same defaults for untrusted requesters. And those are basically that harmless tests like ping and traceroute are allowed. UDP throughput is restricted to 50 megabits per second, and certain resource or schedule intensive tasks are duration restricted. So you could do something that, for example, there's a test called idle exclusive that was something we wrote for debug that basically locks the entire system down for as long as you've asked for it. So for untrusted requesters, that amount of time is limited, I think, to 2 seconds to prevent any kind of big use of it for denial of service. Limits get evaluated at 2 points in a task's lifetime. The first is when it is submitted, and that's just sort of an overall yes, you can do this, or no, please go away. And the second time is at the scheduling phase for each of the runs. Both of these times evaluate it based on the task specification. And when you're scheduling runs, because we now have a time in mind, the proposed time and duration can be evaluated also. And that lets you do things like prevent pscheduler from running certain kinds of tests, say during maintenance windows, and that sort of thing. The limit system, as far as determining who's asking, the limit system is given a set of what we call hints, which contain things like the IP address of the requesting host, the IP of the server where the request arrived. And as we add additional features such as user authentication, then all that information will end up in the hints as well. The limit system also gets the measurement type and its parameters, so you'd be able to look at things and say, this is a throughput measurement, and maybe they've asked for it for too long or too fast, that sort of thing. And additionally, when scheduling runs, you get the proposed start time and the proposed duration as well. So the first phase is identification. That's who's asking, and that takes input from the input that I showed you just a second ago, and applies a condition based on an identifier's type. So we have these identifiers that are used to determine whether or not the requester falls into a certain category, basically. So you can use this to make declarations like the requester is on one of our campus networks. The requester is on a network that we have known to be hostile to us before, and we don't want them doing anything, or the requester is not on a research and education network. There's actually, the possibilities for this are pretty much infinite. I'll just do a quick survey of just what types of identifiers are available. We have one called always that always evaluates true. Excuse me. We have one doing that does text matching on the hint values. We have one that will determine whether or not the requester's IP is a Bogon or Martian according to Team Cumry's DNS base list. We have one that does text matching on the requester's FQDN. So you can do things like reverse resolve an IP address and find out that, yes, it's part of an institution that you're okay with. Got lots more, a couple that determine whether or not the requester is on one of the local interfaces or on a local subnet, one that runs a JQ script. And two, I'm going to talk about a little at length because I think they're sort of they're relevant to security applications, are IP CIDR list and IP CIDR list URL. Both of those operate with a list of IP addresses or CIDR blocks. And they just determine whether or not the requester's IP falls within those. IP CIDR list URL does the same thing, but it downloads the list from an external source, and that's where that's sort of where you get the utility out of this. The address list format for it is it's just plain text separated by new lines and has provisions for comments, and it's just a list of IPv4 or IPv6 individual addresses or CIDR blocks. The IP CIDR list URL identifier has a bunch of parameters. You can tell it where to get the list. You can tell it what JQ transform to apply to it if you want. We did that specifically because there's a list of IP blocks that's published by Amazon for AWS, and it's very convenient to just use a JQ transform to take that. What we get from Amazon is a JSON format, and it's very convenient to use JQ to translate it into the plain text new lines with new lines that the identifier requires. And there's exclusion and also just some information about how often to update and how often to retry, and whether or not you pass it or fail it if you have no list available because you haven't been able to download one yet. So what do you use this for? You can use it for all sorts of things. You can determine things like, who do we like? So you might have a list of campus and perfSONAR nodes that you maintain someplace, or researchers who's registered with you as wanting to do tests against your nodes. Or probably more interesting to the security types is, who do we dislike? And that can be things like intruders that were detected by your intrusion detection system, published block lists, or pretty much anything else that your threat intelligence system can produce, where you can say, I don't want to see requests from this network. The advantage of this model is there's a couple of big advantages. Number one is that you as a security professional get to publish the list and make decisions about what gets on it and what doesn't. And perfSONAR would simply just consume it. And that decouples a lot of the administrative decisions from the perfSONAR configuration. It just becomes a source of data rather than having to go through and reconfigure your perfSONAR nodes every time what's in those lists changes. So there's a lot less maintenance there and a lot less opportunity for things to go wrong. So having covered all of that, let's talk a little about what perfSONAR can do for information security organizations. So historically, perfSONAR has kind of been typecast as a tool for network performance measurement, and we tend to sell it that way, largely because network operators are our largest constituency. But there's really nothing in the current architecture that precludes other applications that aside from doing things like throughput and latency. So on that front, let's stir a little bit of creative thought here and see what we can make perfSONAR do for security. One thing that's kind of come up in various discussions is the use of perfSONAR as a unit testing platform for security policies. We tend to talk a lot about measurements in numeric terms, and that's things like how many gigabits per second can we get between 2 points, or what the path loss is, and those are all just numbers. But Boolean measurements are also still measurements, and a lot of the things that you do in security are asking questions that have Boolean answers. For example, is some host reachable from the inside or the outside, or is this web server serving up a page to an address that it should be or shouldn't be? Or does your DNS server answer external queries for hosts that should be internal only? So to that end, perfSONAR can be used to run those kind of tests at regular intervals. We have a fairly wide variety of archivers that will take those measurements and send them off to other sources. We have HTTP, RabbitMQ, Kafka, syslog. We can send SNMP traps. We have a few more archivers that have actually been added since this was written originally. And we also have the option of taking a no news is good news approach. So if you get a result that sees the expected behavior, you can simply drop that on the floor and only pass along things that are cause for alarm. Additionally, you can leverage PSConfig to control all of this centrally. So again, your perfSONAR nodes just become consumers of what they should be measuring. And additionally, the PSConfig file is all JSON. It can be generated as well. So if you have systems that maybe have a database of what these things are, you can use that to generate the PSConfig from that. In fact, we're going to start doing that at Internet 2 shortly. So kind of one true story from the field, and this story goes back a few years, and is actually one of the things that spurred the discussions about security applications. Was that a very large institution that shall remain nameless at one point fielded a set of router configurations that had a mistake in it, and as a result of that mistake, secure shell access was open to a very large swath of its internal systems. And it stayed that way for quite some time, and it didn't go noticed until some of their other measures started raising red flags. And since then, they've been doing a little bit of research on what they can do to do verification of those things from an externally deployed perfSONAR node. So this sort of leads to the question, what can't you test with perfSONAR? And in theory, the answer is not very much. Everything that I have described so far can be made with out-of-the-box perfSONAR. And anything else that can be dreamt up, we can write pscheduler plugins to integrate them, and all of a sudden you've got them in this test framework that you can control remotely and do all sorts of other interesting things with. Plugins, and again, I think probably most of you have seen this, but we have 4 types of plugins. I'm going to cover the 3 that are interesting. We have test plugins, which describe new measurements. We have tool plugins that are the glue between pscheduler and the programs that actually carry out the tests, and we have archivers that describe ways to dispose of results. So all these can be written anew. We wrote a big pile of them last year. I think probably Ed will talk about some of that in his update with what's happened at the University of Michigan in the last year. But generally speaking, the requirements are just that you have to have a way to describe what you're testing and what its result looks like, and you have to have a program that can produce a result of that test, perhaps with some glue to get it translated into something that perfSONAR will like. The development team, I always mention this when I talk about plugins. If your institution develops a plugin that's of general interest, we are always happy to make those part of the perfSONAR distribution. We may go through a few rounds with you to make sure that it's kind of up to good supportable standards. But it's in everybody's interest, I think, to have more plugins available for everyone to use. So I'm going to talk a little bit about a couple of non-traditional test plugins, and the first of those is called NetReach. And this was a thing that I actually put together for use on SciNet a few years ago to find out if there were any hosts up on a given network block. And the purpose for that, in this case, was to determine if the networks in the exhibitor booths were up and functioning. And it has a bunch of features like it can scan up and down or from the edges in or randomly. You put limits on how many IPs to scan. And optionally, you can either ignore the gateway being up or take that as the network being okay. The thing about this is it gives a simple yes/no result. So it was not actually intended to be a network scanner, although it kind of, I guess it is in sort of a very coarse way. The original version of this was based on Nmap, and last year we found some deficiencies in that, and it was replaced. Actually, the plugin, the replacement plugin, was actually written on the floor at SC last year, but it was replaced by one that's based on FPing instead. The plugins to do this are not installed by default. We did that on purpose because we didn't want every perfSONAR node to become a place to do network probing. So if you want this feature, you have to install the plugins for it explicitly, and it's sort of a if you did it, you sort of you own it type thing. So there is another test called Open Ports, and this was developed by Michigan's interns last year, that finds out if ports on one or more hosts are open. So yes, this actually is a port scanner. And it was, again, developed last year. We have a little tiny bit of work to do to get it production quality. It may show up in 5.0 or it may show up in 5.1, depending on when we get to sanding the rough edges off of that. Again, it's not installed by default, so it's an explicit thing. If you want it, you have to install it. Additionally, you can do topological testing with perfSONAR as well. So you can do things like, or I'm sorry, you can sort of, this is the topology for determining some of these things. If you have nodes that are inside the security perimeter, you can use those to test what happens outbound. And similarly, if you have nodes off of your network, you can use those to test inbound. So you can use your existing nodes for some of this. If you have a lot of perfSONAR in your infrastructure already, those can be leveraged for that. Additionally, you could develop some "we'll test yours if you'll test ours" relationships with other institutions, which might not be such a bad thing. And all this, again, you can leverage PSConfig to minimize the amount of reconfiguration that has to be done on any of these systems. You will, of course, you will probably need to add some nodes where needed. You may not have them in all the places you need. The great part is that the security related measurements are all very low stress, and they really, all they need is very low cost, very low spec hardware. So you can do this on, say, Raspberry Pis or anything else that you can put up for, $50 or $60 a node. Additionally, there are some vendors whose switches and routers can run perfSONAR on them in a container. I haven't surveyed who's able to do that lately, but there were a couple of vendors last I looked. There are some other uses for some of the existing perfSONAR tools. You can do things that like run periodic tests that appear as intrusion attempts, and those can be used to make sure that your protective infrastructure is still producing alarms for them. You can do things if you have, say, website filtering. The HTTP test that's already built into pscheduler can be used to try to retrieve those and determine whether or not they are or are not retrievable. And you can use path monitoring, which is basically the trace test, to verify that your traffic continues to take an approved path through your infrastructure to or from the outside world. That was pretty much all I have. So I think I managed to squeeze it into my 20 minutes here, despite the delay. If you have questions, you can drop us a line on the user list or the development team address, or even me personally. So that's what I have on this. And if you have questions, I'll hang around to answer them. Antoine, I think you're muted if you're speaking there.
Yeah, sorry. Maybe can you hear me now?
Yep, you're good.
Yeah. So thank you, Mark, for your presentation, and we'll take any question now for Mark or other questions from the two other presentation we had in this session.
Hello.
I see there is a general question on the chat about the presentation material. We will post that to the workshop wiki page as progressively as I collect them, and we'll send you a link to it afterward. Yes.
Antoine, I think Olaf was going to ask a question, and then he cloaked himself again.
Yeah, why not?
Tim was talking, but we couldn't hear you, Tim.
Oh.
Oh.
Can you
well,
hear
I can hear Olaf.
I still cannot.
Oh, I see two people nodding.
Oh, it's me.
Okay, three, good. Yeah. So my question was actually, to what extent has perfSONAR being misused for some kind of attacks, or has it been possible in the past to use perfSONAR for doing DDoSes or whatever, or is
it is to some degree, and that's sort of this, whenever we bump into security people, that's sort of the first thing they ask is how can this thing be used as a packet cannon? So the answer is, from a technical standpoint, yes, it is possible, but we try to ship the toolkit, as I mentioned before. We try to ship the toolkit with some sane defaults, so you can't just ask another perfSONAR node, hey, give me full blast UDP, aimed over it at this thing. One of the nice things about throughput is that it actually requires the participation of of 2 perfSONAR nodes. So while you could set something up like that, generally speaking, if you're either running the default limits that we ship, or the site has tightened them up themselves, there's a lot less room for that. Now that said, I had an interesting conversation with somebody at Internet 2 several years ago about developing plugins to basically to flood links as a validation thing. And what I told them was, yeah, that's actually totally possible. But if we did it, it's not something that we would ship by default, because that would be well rife with opportunities for abuse.
So you kept it for Internet 2, right?
Actually, we never wrote it.
Okay, good to hear.
Don't tempt me, Yvonne. I might.
Okay, thank you.
Is there any other question to Mark or to any other presenters that we had today?
I mean, there was an interesting point made by somebody earlier as to sort of what can't you do with perfSONAR, and I think Mark is showing you can think quite creatively. I mean, I was going to say what limits are there, but that's a bad pun. What are there definite no-go areas for what you would do with perfSONAR, or any things that maybe we should be doing that we're missing?
It's funny. I can't really think of much that you can't measure, largely because there's nothing network specific about, and this is more about pScheduler, I think, than anything else, but there is nothing network specific about pScheduler. In fact, I gave a talk last year on how pScheduler works internally, and one of the things, I think it was in that talk, but at some point though, I needed an example of just sort of how the whole process of plugins and measurements and all that work. And one of the things that I used as an example was, there's some company with a warehouse someplace has reason to monitor the state of the garage doors in its warehouse, in its warehouses. And maybe they have these nice network connected garage door openers that can tell you maybe open or closed, or what direction, or how far up or how far down. And you basically, as long as you can say, this is what I want to measure, and this is what the result looks like, and oh yeah, I've got a program written that will get that answer, you can glue that sort of thing into perfSONAR if you want. So, I mean, whether it's garage doors or stock prices or network throughput or anything else like that, odds are really good you can write a set of plugins to make that stuff work.
Yeah, and I think theoretically a lot of stuff is possible. The only place where I could see you can get into trouble is just if you're talking on a really high scale, or like a large volume of data that you need to ingest. And then, theoretically you can write programs that'll do the translations, but can they keep up, and pScheduler keep up, would be the only thing I think. So, even thinking of like metrics like flow data, or we even have an SNMP plugin, but for any reasonably sized deployment of SNMP, that's probably not gonna keep up. And that's just because we haven't designed it to be like a super high throughput collector or anything like that, and that's really not its niche, right? There's other good stuff out there that does that, but I mean, in terms of being able to process some input and generate some output, it's just a matter of code. So
everything's just a matter of code,
right?
So one question then, I think what Mark says is, I think it's true and interesting. So if, let's say, I had a garage door that I wanted to, and I had some API to test whether it was open or closed, is there guidance on how I would write something that, and I put perfSONAR on a Raspberry Pi, how I would actually do that integration to actually put that test in and visualize the results for Grafana or something? I mean, there's a certain it's very easy for a perfSONAR developer to do that, but if we might want anyone to just pick this up and use Pi running perfSONAR and pScheduler as a way of doing that sort of thing for various devices they have, how far away are we from making that easy for them, and how much magic do they need to know?
Well, I think there's a little bit of it, and Ed put a plug for the plugin development kit into chat there, so I'll cover that, I guess. So we have a few things that make the process easier. The first is the plugin development kit, which is basically a thing that has templates for templates for the various standard types of plugins, so that you basically stamp one of those out, and there's sort of instructions, and it's kind of paint by numbers. It says step 1, do this, step 2, fill this part of the code in. There is a little bit of kind of old documentation actually on how to on how to write plugins, and I think it's been covered a little bit in previous previous webinars. But it is, in a lot of ways, it is sort of still I had intended for it to be a little more widespread so that more people could use it. But I think some of that is a matter of documentation. We have had a couple of things where we've kind of worked with third parties on getting plugins built for for their things. The Ether plugin, for example, for throughput, is an example of that. They sort of gathered the necessary expertise on the tool, and we work with them on building it. But yeah, we're a little deficient on that front, and that I think is just it's sort of a side effect of being a big project with a small staff, I guess. I think Otto, you have your hand up there. Do you have a question?
Yes, yeah, kind of question. If I would like to do some more continuous measurements, perhaps you could you to explain to what degree I can use perfSONAR to do continuous measurements?
Well, funny you should mention that. I actually have an entire talk on that tomorrow.
All right. Okay.
I'll give you a brief answer though. At the moment, internally, we have support for pScheduler has support for tools that generate a continuous stream of results, and we use that. If you're using the POW stream test to do continuous latency measurements, that was the case that was built for, and there are some, this is, I guess, kind of a preview or a plug for tomorrow's presentation. There are some limitations to that we're starting to see in high scale environments. And we're looking at better ways to do some of that stuff. So that's going to be the thrust of tomorrow's talk. But the infrastructure is already there and has actually been there since the first release that had pScheduler 5 years ago. So if you come up with a tool that does those sort of things continuously, integration is not difficult at all.
Okay, super.
All right, good. Thank you for all these questions, and sorry again for my headset issue. As we're running a bit out of time or running into the other session already, but we were planning going for a break, and it's probably good that we all take at least a short break. So we have a bit of buffer time at the end of the last session. So I would suggest that we take a 10-minute break now, and that we start over, or maybe a bit less than 10 minutes, maybe 8 or 7 minutes, and that we start over at 2:10 UTC time. So in 7 minutes from now, with the presentation from Otto. And thank you for your question, Otto. And I think your presentation will explain why you asked this question.
Yeah, a little bit.
Okay, so see you all in 7 minutes. Okay, good. Welcome back, everyone. So we have now the last session of today's workshop with 2 presentations. The first one is from Otto from SIKT. He will talk about MicroDep and perfSONAR. And then we have a presentation from Ed that will update us on the perfSONAR usage at University of Michigan. And so I hand over directly to Otto for his presentation.
Thanks, Antoine. And as you say, I'll try and present for you MicroDep and what it has to do with perfSONAR. Well, first of all, what MicroDep really is, and how it relates to perfSONAR today, and hopefully also in the future. And this is really all about end-to-end monitoring to improve inter-domain routing, first of all. And as well, my question indicated in the previous session, that it's really continuous end-to-end measurements we are working on with this MicroDep project and toolset. And well, a slide here to motivate a little bit why we want to do these continuous end-to-end measurements and why we think they are of significance. But first of all, end-to-end measurements, as you probably all agree with me, that they are really important to reveal what's actually going on through the whole network. So if you don't do these end-to-end measurements, you risk to have some certain level of end-to-end blindness, as we've tried to coin it, by just monitoring individual devices throughout your network. So as a network operations center or a NOC, you should really also know what it looks like from the customer perspective, and end-to-end measurements can give you this perspective better than just measurements from individual network devices and links and boxes. And also, of course, you can by end-to-end measurements, you can monitor inter-domain aspects and get an idea of what's going on from across multiple networks. And by having them continuously measured, these end-to-end measurements, you can also have an early problem awareness, so that you actually know hopefully what's going on, if there are glitches and problems in your network or your neighboring networks, before your customer starts to, or the user starts to call into the NOC and complain and wonder what's going on. That's kind of a nightmare situation, I guess, for a network operational center, that they don't know what's going on and the customers are calling and complaining. And then, of course, these type of measurements, they will definitely help to evaluate and improve routing and forwarding, and also they help with debugging in general. And as many of you already do and know, is that these end-to-end measurements can help you as users to ensure that you have the necessary network resources and network connections towards critical applications and usage cases at the right moment in time. And also, perhaps you could easily differentiate if there are issues in locally somewhere in the network and more externally and other places. So enough motivation there. There's a list of examples here what we have discovered with our continuous end-to-end measurement system. We've discovered some misconfigurations in an MPLS transport in US, which caused a periodic 2-minute update, an outage in a connection, sort of a long-distance connection. We had discovered some 30 minutes routing, stopped routing in the GÉANT network at some point because of a router upgrade failure. And we also have realized that we have been living with the 2-minute failover time in our Norwegian end-to-end network for some customers between their primary and secondary connections, because of suboptimal configurations in the routing protocols there, and so on. There are several examples here, which I'll leave it to you to read there. So the system I'm talking about here, doing continuous end-to-end measurements, is at the current point of time not perfSONAR. It's a similar system indeed, and we call it MicroDep, and it stems for quite many years back. As far as I understand, it's sort of started being developed in parallel with perfSONAR a decade back at least. It was initially just a sort of experimental measurement project, but today it is a set of measurement tools, system, and also an ongoing project. And the core objectives, they are to essentially reveal network dependability issues at a fine-grained level by these end-to-end measurements. So fine-grained and dependability are sort of key terms here. We measure with a rather high frequency of probing packets, and we try to figure out, to measure, to filter out negative events with respect to availability and other parameters which are covered by the dependability term. So that's essentially why the system is called MicroDep, fine-grained and dependability focused. And another objective is, of course, as mentioned already, to in general do what we can to improve routing configurations and the efficiency of routing in our network, but also in general in the global internet, because our users, they use not only the national network, they are very dependent on the whole internet and all the other endpoints, and that they are routing as efficiently as possible. So I start off with a kind of a top-down presentation of the tool here, MicroDep. This is one of the interfaces we have, sort of the startup interface. We have also chosen to use a map showing the measurement topology. So we have all the nodes we have in operation in our measurement network, and we have chosen to draw some lines between these nodes to indicate which nodes are currently measuring towards the other nodes. And we also colored, I mean, so these lines are not at all showing the actual path followed by the flows, merely indicating that there is a connection between two nodes. Coloring depends on the type of measurements you study in the view here, and what we focus on is events, to present events found based on the data sets we collect. So it was really encouraging to learn that from the other earlier presentations that there are, of course, maybe not surprising, other people also extracting events and using events as sort of a source for alarms and source for making perhaps decisions based on the data collected from measurements, instead of just visualizing the data sets, the raw data sets, and sort of leaving it to the human eye to detect events and anomalies. So here we have in the map view here, there's a drop-down list showing there a list of events we currently extract, type of events. We have gaps, queues, and route changes and route errors. The route changes is sort of recently added, and it was interesting to learn from an earlier presentation here that there are also other people working on trying to figure out how routes change based on trace route measurements. So I should definitely look at what you're doing. Right, so you can choose between these different type of events data sets, and you can also within these data sets choose different type of variables or sort of measurement values, which we have per event type. And you can also click on each of these links in the map and have a look at the aggregated values for that connection during the day in this case, and the date and time, and get an impression of why the link is yellow or red, for instance. So we have top of this pop-up windows, we have some statistics, aggregated statistics, in this case for gaps, big gaps, small gaps, even some jitter and queue numbers here, and also sort of in general an availability. Then also there's a list of the actual events detected during that day at the bottom of the pop-up menu. So we see we have what's visible in this example is what is it, 5 gaps we've found, but they're not really that large, 70 milliseconds, 60, so minor gaps observed during this day on that link. We have also some other views which you can use to study the events, and to some extent also the raw data being generated by the system. You could get some classical diagrams showing a sequence of events over time, and we also have a heat map similar to what you see in perfSONAR viewers, instead of the sort of giving really the same picture as the same data as you have in the map, but more as a matrix where you can perhaps easily detect if there's one node underperforming, and that's, I guess, what we see in the example here. We have one node which is suspiciously red all over the place there. We also have a trace route viewer we've developed, which is quite useful. It tries to aggregate all the trace routes collected during one day and then make them available as a graph. So it's a sort of get a rough idea of the topology your packets traverse through from an end to end. And also we have just a sort of an aggregated table similar to what's available in perfSONAR, I believe, of the hops and how often these routers are seen during the day. All right, so what's under the hood of this system? Well, it's really what you would expect. It's some traffic generators, a source and a sink in each end of the connection, sending 100 packets per second, so a rather high frequency of packets, again to get this fine-grained level of measurements. We run a trace route per minute, 60 per hour, parallel to the probing traffic, and then also we listen to ICMP responses from the network using TCP dump essentially to see if the network itself sends some information back to us, which could indicate problems. And we managed to we have 50 nodes internally in our network running, so it's essentially machines, servers, and we also have 24 nodes globally in the topology, mixture of physical machines and VMs. Yes, actually, I also have 8 VMs in data centers around the world, which is quite useful. So we try to, by that, we can get an impression of the actual quality towards the big data center players and what our customers experience of glitches towards VMs in those places. So this is very similar to, of course, what you know. This is what perfSONAR also provides, but at a larger scale, indeed. But we have these real-time event analysis as sort of an add-on to our system, which we believe is quite useful and if not unique, it has some significant value. And it's actually scripts running continuously and sort of chewing on the data sets right after the measurements has been done to filter out packet loss, queuing events, and also route failures and routing changes based on the trace routes. And we also have recently added some code to correlate packet loss and route changes to try and generate new events for those situations where we can suspect that the route change actually causes packet loss. And we have also started to investigate, to spend some time on looking into if machine learning then can be applied to do more interesting, perhaps event extractions or even correlations between events. But so far, I mean, we see that you could actually do a lot without throwing machine learning on this. So simply by using common sense and some good logic. And we do indeed have an integration process ongoing with perfSONAR. So what we see is sort of something we would like to bring into perfSONAR is this real-time analysis part. The rest, understand and admit is something probably perfSONAR can handle maybe even better than we do with our infrastructure. So to have a look at that integration situation, we try to compare what we have in MicroDep with what we know perfSONAR is offering. And from an architecture point of view, it looks something like this. So MicroDep has a set of viewers, which perfSONAR also has. We have some storage backend. It's actually based on Elasticsearch, our event database. And we also have a raw, just file store for the raw data sets measured. We also have some config system offering config to our nodes, centralized config system. And this is very similar to what's offered by perfSONAR. We have less developed scheduling layer. We have to admit, we're just using crontab and some rsync and a file beat, sort of in separate processes to manage scheduling and collection of results and feeding them into the storage system. Then we have traceroutes and our root CRUD, which is the traffic source and sink tools, which is pretty much possible to replace, we believe, with of course traceroute in the perfSONAR suite, and we have the WAMP tools here, especially the POV stream tool could probably replace the root CRUD tool set in the near future. But then we have these analytic plugins, so to speak, analytic modules running together with the measurement tools, which essentially eat the data directly, more or less, from the measurements tools, and then interact with the collection system and also with the database system to produce and store these events. So, kind of a suggestion that in the future, probably not in, very likely not in perfSONAR 5, perhaps 6. We hope to see MicroDep integrated, maybe something like this. Already we see that the backend is turning into Elasticsearch, so this should be fairly straightforward to move our event index into this system, hopefully. Of course, all the viewers, they are web-based, so this probably is not a big deal to add these to the viewer collection. We might need some extra plugins for the pair scheduler to run our types of continuous tests. And maybe also some adjustments done to the poll stream to make the tests continuously enough, to make them fine-grained enough, real-time enough to be able to recreate what we have. And then there's maybe an archiver plugin required also to ensure that you can store raw data next to the ES database. Or if we dare, we could of course stuff the raw data also into ES. Depends on the sort of the capacity of the system envisioned by perfSONAR 5 and future versions. But then we have these analytic components, which I've put down here, and I guess this is probably a challenge to the architecture of perfSONAR, that we now have some components here which not only feed information and events into the pre-scheduler and upwards to the storage system and viewers, but they also require some input from the system. So this is probably something which is a little bit tricky to support currently, as far as I understand, but maybe there is openings for this in the future, we hope. I could do a quick demo, but I guess I'm probably run out of time now, haven't I?
Yeah, we're a bit, yes, yeah, we're a bit out of time, but
I'll skip that.
Maybe, yeah. Okay.
So I just leave this slide up, and you can visit the web page there, MicroDep unit NO, and look around, browse around. It's openly available. And well, if you would like to contribute to the current network by installing what's necessary of tools to run a node and include it in our system, there is a short recipe here, and we really would like to have more nodes globally. So please just visit the webpage and don't hesitate to contact me and Olav if you have questions about this.
Okay, thank you.
I think I stop there.
Yep, thank you very much, Otto, for this presentation. Maybe we can, if people are interested in, if you still have time after the end of the workshop, Otto, maybe we can extend a bit for persons interested, and you can do a demo if anyone's interested after all the presentation at the end of the workshop.
Yeah, good.
So I see that Ivan has raised his hand and has a question.
Yes, and I'll try to make it, a limited one. So actually, Otto, I believe you mentioned somewhere that your measurement systems are of a small factor, or kind of do not require much resources. The question is that comes from the analytical tools that you just showed in the integration proposal or idea. So do you suggest that these tools are running along or on the systems that do the measurements themselves? I mean, are you not able to make the analytical part based on results that are collected on in the archive, or I'm not sure, in the data store?
Yes, sure. You could of course transport the results to sort of a central node of some sort.
You are anyways doing that, right? I mean, you're not sending only the analytical part, you're also sending the raw results, or?
Yeah. But we send the raw results in a more batch-oriented manner at a point in time during the day, around midnight.
I see, at batches, okay.
And so doing it in a controlled way, so that we are sure that transporting the sort of the bulk of data is not influencing the other measurements, or influencing them as little as possible. So it's really to sort of be able to have these events available in real time. We realized that putting these analytic small pieces of code out onto the node is valuable. So then we can just move or stream the sort of the events we discover in real time back to the central node. And then we do sort of once a day, we do a more batch-oriented transport of the rest of the results.
So as a conclusion, so these analytical parts or the analytical tools are not CPU intensive kind of, and you're suggesting that a small factor systems we are doing quite well.
Currently, they're doing rather simple analysis, I would say, so they're not really very intensive. But I mean, there is a potential for doing more, of course, more statistical analysis, for instance, of the data sets, and then it might turn into an issue with respect to resources, I guess, on the node. And I guess I'm thinking that so that's why I place these components underneath the P scheduler in hope that the P scheduler perhaps could be a component that takes care and makes sure that these analytic tools do not overload the node.
I see. I'm not sure if I understand correctly. You have a concern that streaming the data from the measurements directly to the archive. During the day, not at POC, but constantly, continuously, will kind of affect the measurements themselves, and perhaps that's why you prefer doing that. It's in books, but then again, anyways, you have to transfer that data, and then you will see some impact of the
yes.
And then you have to account for that in the measurement results.
Yes, yeah. So well, it's a.
Is it that much data that it has an impact?
Not currently. I mean, it depends really on the topology. I guess we divide.
And the number of measurements, I guess.
Number of measurements, entering one node or having one node as a destination. If there's one node which is receiving a lot, then it might be an issue to transport this out again. But yeah, no, it's a very good question. So it could perhaps with some
split interfaces
fine-tuning be possible to actually transport everything to a central node and then run the analytic tools there. That
yes,
might
okay.
also still be an option. Yes, right. But from experience, I mean, we sort of moved from having a rather somewhat batch-oriented system, and then to make it streaming, we chose to move these analytic tools out onto the nodes, and it seems to work well today.
Okay,
but I agree, it might not be the ultimate solution.
Well, I believe it's Mark is here actually, but pScheduler with its plugins can transform the results, or kind of you could have a plugin for the analytical part and then submission to the archive. So your analytical tool can be actually an archiver which collects the data, and then after transforming it or making the correlations or the analytical part, then can send both the analytical part and the result or something like that.
Okay, that's an option.
Yeah, I think probably there's a larger discussion with the developer team we should have. Yeah, I mean, when I saw that architecture diagram, there was a bunch of tweaks I could see, but a lot of it depends on the rate that you guys really think you need. And things like that. Because I mean, I could argue too that you should have your analyzers on top of a message bus, which pScheduler could write to. But then again, that depends on how fast you guys think you need to process that for your use cases and how often it writes, and probably stuff we don't have time to get into today. But
no. So
that was very helpful for understanding your application. So
I have to admit, Good. Yeah, I have to admit I don't really know perfSONAR by heart. So I mean, you guys know this much better than me. So if you see that there is a possibility to actually move this system into perfSONAR without having to do fundamental changes to perfSONAR, that would be really great.
There are a few tricks we have done. To avoid the problems you're talking about, the first thing is that normal CPUs today are multi-CPUs like 8 cores or more, and this system measurement node just uses about 10% for analysis and packet generation and collection and everything of one core. So we are down to a few percent. So I don't think this is a performance problem, and it's not a problem that we do transport data with TCP. The UDP buffer space, which we use a lot for the measurements, could be limited, because we have too many arriving packets at 100 packets per second. So that's a scarce resource. You'll have to configure the system to have enough UDP buffers so that you can process all the receiving incoming packets in time. So that's a present problem we have. I don't think we have this batch processing problem at all. That's my impression. So this is an open discussion with Otto, which is my project partner. But so I'm not that concerned. But anyhow, and we use kernel timestamping for the incoming packets. So it means the timestamps get into the packet when it arrives from the interface card. So the timestamping is not very much, let's say, it's not influenced by internal queuing in the CPU, or if you have a highly loaded CPU, it doesn't really destroy the end-to-end accuracy of measurement for delays. So yeah, I have dived a bit into these details, and yeah, I'm not that concerned. Yes, sorry for.
Okay. Yeah, no. Thank you for the comments, and thank you for the questions, and thank you for the presentation, Otto. We're running a bit out of time, and this discussion is probably a bit too technical, but this is a discussion that will continue within the perfSONAR development team, and together with you, Otto and Olaf, I think, because we see that there is some potential of having MicroDep use perfSONAR to do the measurements, and perfSONAR to benefit from MicroDep analysis and result presentation as well. So we're interested in taking this further. But for now, let's close this discussion and keep it for another time. And I will hand over to the last presentation for today. And sorry for being a bit out of time with the agenda, but now is Ed from University of Michigan with his presentation.
Well, hello, everybody. I'm Ed from University of Michigan. I'm going to cover a lot of material in a short time. So if you could please put your questions in the sidebar, and we'll try to circle back, and I can stay a little after if need be. So first off, the thing that I discovered when I took the job of being the perfSONAR guy at UMich 6 years ago is that we have a pretty healthy infrastructure. We've got, before I get too deep into this, I wanted to say that this comes from a campus perspective. A lot of the other talkers and problems we've seen have come from sort of like an ISP level. This is sort of the story of some problems I encountered performing perfSONAR duties on campus. So we have multiple 1G and 10G test points. We've got visualizers, data archives, the PWA. And basically, when I took the job, we wanted to revamp our architecture or infrastructure. And after we bought some new machines, it took a team of sysadmins and myself, who was admittedly pretty novice at the time with this, almost an entire week to upgrade and integrate our perfSONAR cluster. So that was not tenable if I was going to ever do anything else with my life. So we decided we would solve this problem of scale on the campus with automation. So we chose Ansible for various reasons. It's agentless. It's an industry standard. You can reuse your inventory for other projects. And basically using this solution, oh boy, now there we go. Using this solution, we came up with playbooks and roles that we have submitted and maintain in the perfSONAR consortium main source. And it basically provisions and configures all of the infrastructure for us. And it also manages dependencies. So there's other talks on how we do this, and I'd be happy to expound upon that some other time. But basically, it turned this week-long endeavor into an exercise where we spent the majority of the time configuring what we wanted with Ansible, and then the The last bit of it, we let Ansible enact those provisioning and configuration steps for us while we basically just watched and drank coffee. So the other problem that we have on our campus is that we have a multitude of buildings, upwards of 100, and there's just no way right now that we have the resources or man hours to provision perfSONAR nodes to all of those places. So we have them strategically spread across our campus, but not everywhere. So if we get a report that there is a perceived performance issue with one of our buildings, we have developed this technique of bringing 10 gig perfSONAR nodes to different places on our campus to do end-to-end testing. We started with traditional servers, which were very unwieldy. They were the size of pizza boxes. They weighed 45 pounds each. And we found, thanks to Moore's Law, everything gets smaller and faster every year. We can fit 2 of these super micros into a backpack and take them on campus. We have a special, we tested this out to make sure it's just as performant as a regular network configuration, but we actually use interface bonding. So a tech can take one of these into the field and not have to know how to configure anything. They can plug in the 1 gig, a 10 gig short range or a 10 gig long range. And the OS CentOS in this case just handles that port bond internally, and it does exactly what the network tech wants. It'll talk to that piece of hardware. So you can see that we have on the back of this hardware these different interfaces. We have them marked up so they know what to do. They provision them at the place where they want, and then they start testing. We have on our IPv4 range, we have a special /29 subnet that we use to provision these. Basically, using this, you can have 2 perfSONAR test points, and we have some dual homed buildings. So this is required so we can test both the gateway and both of the distribution layer routers at the same time. So by IPing them like this and having this published for our techs, they basically, they go out, they build the VLAN to the site, they plug in the hardware, they ping the device from the network to make sure they have connectivity. And then they don't even need accounts on these boxes because it's running perfSONAR. They just get on a perfSONAR bastion host and they tell the 2 hosts to run throughput and latency between each other. It's very high security and low stress. So the technique is pretty simple. We take it out, we test the same physical path that the user has. We test the shortest path possible, and then we widen the path out as until we find the possible source of the problem. We pinpoint it, and then it's then we fixed it. So the other thing University of Michigan is known for is we develop a lot of plugins for the perfSONAR consortium. We developed the plugin development kit, and last summer, our very own Mark Feit, he's a honorary University of Michigan alumnus at this point. He spent last summer helping us integrate a bunch of plugins that you're going to see in 5.0 using the plugin development kit. The plugin development kit streamlines this. Like Mark said before, it creates a structure that you can then paint between the numbers. One of the other things that didn't really get mentioned was that when it creates this structure, it creates a minimum viable perfSONAR test. All it does is sleep. It does nothing else. But the advantage of that is it's built in to perfSONAR at that point. So when you begin to make your own modifications, you can see when you broke it. So that way you can, try to figure out what you do to get it back working. Last year we used Vagrant as a software development environment. It worked great. You can try out multiple OSs, and because it's a virtual environment, you can set up a multitude of targets to test to. Very low overhead. So last year we did this plugin development effort. They're going to be showing up in 5.0. We included Ookla's speed test. There was an open source client for that. I'm sure a lot of your user base is already comfortable in using this. Different ISPs want you to use this to benchmark performance. Now perfSONAR can do it. We've got it's an internal pscheduler test included now. So you can actually query pscheduler about its internals and see some internal diagnostics exposed. We have, Mark mentioned earlier, the net nmap-like test. This is the open ports test. You can use this to probe for security, or one of the other issues that we have is when we stand up different test points, we want to know about firewall connectivity or lack thereof between test points and archivers and such. And you could stand up a perfSONAR node and then use this to see if indeed it could phone home or if it could be reached externally. All very useful things. So this is an example of it running, some of the data it generates, good diagnostics. We also have a wireless monitoring effort that we're doing here at University of Michigan. We did most of this as a standalone program for a while, but last year we had the opportunity to include some of this into perfSONAR's core itself. We have a BSSID scanning tool. You invoke it and you can basically pull off of the wireless card a list of all BSSIDs and their metrics. So that way you can sort of find your access points in a certain area. We also have a .1x test, and this will help you by authenticating to your network's 802.1 infrastructure. This is done for layer 2 auth on Wi-Fi. I believe that SUNET was also working on another test tool pair, and they had a component of this. And I just want to say, if you want to, this works over the wire as well. You can use it for wired VLANs. We have for layer 3 auth. Whoops, that went too quick. Why? It hates that slide. Look at that. So for layer 3 auth, we've got a DHCP response time. You can ask it for DHCP leases. It'll give you metrics about how long it took, whether it worked or not. This is a useful metric in and of itself, but we're actually using it to do auths to wireless. We've come up with this active Wi-Fi monitoring system we're calling PSSID that leverages perfSONAR. We're using Ansible to provision and configure it. Our use case is to put it in a highly congested area and be able to correctly determine the coverage of wireless APs. So some other products, they just work at the SSID level. You know, you put a device in an area, it connects up like a user would, it gets a solid signal, it starts to do its thing. That doesn't tell the full story. If you have multiple access points and some of them are performing well and some of them are not, the previous method might not be able to determine that. Furthermore, if you have redundancy, if you have multiple access points, and you're using SSID level measuring only, you're not going to notice that 2 of your 3 access points are out until your 3rd one goes out as well. This method actually, by scanning for individual BSSIDs and testing against individual BSSIDs in an area, gives you a more full picture of your redundancy and your actual performance of the devices in that area. So you can see that we are testing Wi-Fi in the building, and we're testing from one of our nodes to an in-building access point. That in-building access point trunks out to a data center where we have different Wi-Fi controllers and network infrastructure, where we also have the closest link to a perfSONAR server. So you can test the shortest link possible from where your users sit to the data center where the Wi-Fi trunks back to. After that, you want to be able to assure your users that they'll be able to use network services like DNS, HTTP, be able to reach external internet targets, and be able to use perfSONAR to benchmark latency and throughputs to those targets. So that's one of the reasons we're using perfSONAR. Like I said before, if you've got a scenario where you've got multiple APs and mixed weak and strong coverage, this will be able to determine for the strong coverage network metrics through active testing. It'll be able to report on stuff that is weak coverage, even if it doesn't test it. It'll be able to say, yes, I saw this, I saw its signal strength, and it'll be able to put that in our ELK database that we're using for this project. The way that this does the testing is we have PSSID located alongside perfSONAR on a hardware probe. PSSID asks for a BSSID scan, uses the results to correlate the differences between the BSSIDs and the SSIDs and what it should be scanning and what should not. And then it uses perfSONAR to actually run active testing against these BSSIDs. So what happens essentially is perfSONAR 5.0 also contains a batch processor. You are no longer required to feed perfSONAR commands one at a time to pscheduler. Instead, you can give it this batch process, and thanks to Mark, the batch process also supports conditional logic. So we're handing perfSONAR 5.0 a batch request that says, first, could you do a .1x layer 2 auth for us? And if that works, could you then do layer 3 auth with DHCP? And if that works, I want you to run this suite of tests. And one of the advantages of doing this via a batch is that when it goes to running the actual suite of tests, perfSONAR knows that, you know, your latency, your HTTP, your DNS, all of that can be run parallel concurrently. So it does that, and then it schedules the throughput to be exclusive, and it cuts down on your time dramatically if your previous strategy was to, you know, do a latency and wait for the results, do a web traffic, wait for the results. This sort of lets perfSONAR handle all of that scheduling logic, and it also lets you authenticate to your Wi-Fi targets with the conditional logic. So there's a whole lot. Our audience really are network Wi-Fi techs, and they're not going to be wanting to plumb the inner workings of perfSONAR. So we're going to stand up a web UI for this as well. And perfSONAR 5.0 also is coming with new features via REST, where you can ask it, you know, give me a list of all the tests and archivers that you support. Once you have that list, you can then query those results one at a time. And you can say, could you please give me all of the features that throughput supports? And then once it gets that information, it can dynamically display those options via the GUI so that someone can come in and elect, you know, oh, I want packets this size, or I want this attribute or that attribute. This is very good because previous web UIs required us to hard code the UI for tests and tools. Our hope is that when people develop tests and tools, that they'll immediately be available via the UI from now on. So that way there's no extra effort to get you know, PSSID and hopefully eventually PWA to do dynamic UI displays for these different attributes. That's coming. Let's see here. And then this was obviously a pre-pandemic slide because of the economics involved. I hear that has changed dramatically since then, but this is an example of one of our Wi-Fi probes. We call it an armored Pi. The only thing exposed is the 1 gig copper Ethernet. We do power over Ethernet into this literal black box. All the hardware with all the stuff that we need to put these probes on our campus. Pre-pandemic, they topped out at about 100. Right now, there is a shortage of Raspberry Pi hardware that you can see if you go try to buy one. Scalpers are charging 3 to 4 times for just the CPU at the moment, but our belief is that when things calm down, that will too. So I've covered quite a few topics here, and I'm going to stop my screen share and say, does anybody have any questions or want me to go over any part of that again?
Yeah. Thank you, Ed, for your presentation.
Okay.
Thank you for making just right on time. Any question for Ed?
I think it's great. They're very, very good talk. So good. I can't think of a question to ask. Thanks, Ed.
This summer's project with our interns this year is to finalize the Wi-Fi PSSID system. So it'll hopefully at the end of the summer, we'll present again. It'll have a GUI and it'll work, and we'll have a field deployment, and it'll be provisionable, hopefully via Ansible, so that it won't be a one-off here. Our goal is to have other institutions adopt it if they so choose.
That's very good. I mean, the one question I should throw in, because I'm stereotyped to it, do you have IPv6 at your university and therefore an environment in which you can test those features? And you talk, for example, about getting DHCP, but you would equally in a v6 environment want to see that you're seeing router advertisements and maybe not bad ones.
That's a good question. We do have IPv6 infrastructure. I will freely admit that right now we're not testing all of the features against it, but that is something that we intend to do in the long haul.
Great. Okay.
We're not going to be we're not going to test a whole lot of other third-party vendor products with it though. So you're going to have to wait to see if it's integratable with SolarWinds, Tim. So
yeah, I've heard good things about SolarWinds and IPv6. So.
Yeah. Well.
Great. All right. Thanks, Ed.
Okay.
I have a question. So Ed, you said you're using these batch processing tasks. So, but then how do you account for the time that they should run? I mean, because pscheduler needs to put that in the schedule and know when that will finish. And
so that's a great question. Our architecture is that each one of these probes has pscheduler running in sync with psid, and for our model, we're basically restricting pscheduler to only accept queries from psid. So what psid does is it'll hand off one of these batch processes, have a good idea of how long it should live, and it'll block, it'll wait for pscheduler to finish. And then it doesn't really worry that there's any contention in the schedule because pscheduler's internal schedule should be blank. Instead, it gives its batch. It knows how long the batch should run with some pad. If the thing goes over that time, it kills the batch and says, okay, well, the train went off the track somewhere. I'm not going to be able to figure out where. So we'll move on to the next thing. And if you're in a situation where there's some catastrophic failure and nothing is ever working, then we also have some stuff we're developing on the ELK backend, where if a probe hasn't sent coherent data in a set amount of time, it gets flagged. And sometimes these probes walk around, sometimes the techs move them, and they get flagged and they're like, oh, that's because that probe moved. Sometimes they get flagged and they're like, oh, that's because that probe's dead. And then we'll send somebody to check it. Actually, the first level of triage is to cycle the POE to do like sort of a remote reboot, and that fixes things a lot of the time. But if it doesn't, then it's time to send the tech.
But then that means that you are not using that same device for another batch. I mean, there is no competition there, you know, because I'm not sure how you are accounting for the task time, and so that pscheduler is able to, you know, to order them in the schedule.
You don't actually have to worry about that, Yvonne, because it's basically what happens is the batch processor will throw this stuff at pscheduler. Pscheduler will figure out how to schedule it and get it run, and then the batch processor sits until all of it's finished and returns the results.
Okay.
I think at this time last year, Ed, if I remember correctly, I mean, PSID was sort of juggling all that internally, and now that we have batch stuff that it can.
PSID would scan for BSS IDs. It would do a layer 2 and a layer 3 auth, and then it would use perfSONAR to run individual tests one at a time. Now this year, we will hand off all of that, the layer 2 auth, the layer 3 auth, all those tests as one batch process to pscheduler, and we'll block and wait for the result. And if, like I say, if the result takes too long, we kill it. If not, we end up in a situation where we just launch the next one. And we have perfSONAR doing all the archiving for us too. So we're sort of fire and forget, you know, we're like, okay, perfSONAR, run this batch of tests, send it off to this archive. And then, you know, data analysis is someone else's job. You know, we're just kind of, PSID is now basically a big orchestrator.
Yeah, and you drink coffee.
And yeah, that's what everybody does, right, at work, you know, so. That's about it.
All right, thank you. Thank you for these questions and comments. Is there some other last minute questions? If not, then I would like to thank all presenters for today, for the first day of our workshop. We just run just a bit out of time, but that's fine. If people are interested in a MicroDep demo, and if Otto is still available, maybe we can continue with that. But I would like first to close the first day of the workshop and to invite you to meet again tomorrow at the same time as today, and to continue the discussion and the presentation with perfSONAR and the different usage we make out of it, and the new features that are coming in the next version, and the roadmap going ahead.